여러분 안녕하십니까? 니콜라스입니다. I made a game called KIMCHI-RUN. It is a game inspired by Gimjang season, where I run through a Xijang collecting Beju, Gochu, and Manon, while avoiding Pedalajoshi's and Xijang harmonies. The game is now published on the web and app stores. I made a tutorial to show you exactly how I built it from scratch. So if you follow along, you will have your own KIMCHI-RUN by the end. The tutorial will take you from knowing absolutely nothing about game development to building and publishing your first game with Unity 6, which is shockingly easy to do. Making a game is something that almost all developers have thought about doing, but don't actually do it because game development can seem intimidating. Well, it turns out that it isn't, and apart from being easy, it is incredibly fun to do. Way more fun than making frontends, backends, or mobile apps. When making a game, there is instant feedback to everything you do. You can see results immediately, which motivates you to keep going. As you will see, with Unity 6, going from nothing to having a character that moves around, jumps and avoids obstacles takes no time and very little code. Let me show you what we are going to build. KIMCHI-RUN is an infinite runner game that takes place during Gimjang season. To score, Hungry Nico has to survive for as long as possible without losing his 3 lives. Tripping over an obstacle costs 1 life, and collecting a kimchi ingredient restores it. Collecting the less common but valuable Gum Pechu and gives Hungry Nico 5 seconds of kimchi power, where nothing can hurt him. Building this game will teach you about Unity 6 concepts like physics, cameras, collisions, sprites, animations, storage, and much more. We will learn how to export the game to multiple platforms and how to publish it to Unity Web, which just got a huge upgrade, by the way. Unity 6 made the web games way better. Memory limits are doubled, and they finally added full mobile browser support. You can play the game straight from your phone's browser, and it will run just as smoothly as if you downloaded it from the App Store. Because most people that start tutorials don't finish them, to encourage you and to make sure that you actually finish this one, the lovely folks at Unity Korea came up with a challenge for you. Anyone that follows this tutorial until the end, publishes and submits the game, will get awesome Unity stickers. And the best submissions will get Unity merch, such as Unity laptop sleeves, slippers, hoodies, and backpacks. And the best submission will get brand new AirPods Max. The challenge will be live from the 15th of December to the 30th of January. You can either finish the year strong by publishing your first game, or start the new year like a boss by learning a new skill and publishing your first project of the year. The only requirement to be able to follow along is to be a developer of any kind. As long as you know how to code, even at a beginner level, in whatever programming language, you will be able to follow along just fine. I promise you that even if you haven't written a single line of C# code in your life, making your own KIMCHI-RUN will be a piece of cake. The hard part of making games, which is making the assets, characters, animations, and all that, is already done for us by the design team of Unity Korea. So make some time in your schedule, and the challenge will be officially open. So go get yourself a nice warm cup of coffee, a nice warm cup of tea, and let's get started building our KIMCHI-RUN. For this, we're going to go to unity.com/download, and here we're going to download something called the Unity Hub. The Unity Hub is a tiny software, so the download will not take a long time, and this software is the installer of the Unity game engine, and actually the installer of other packages and other software that we are about to see later. So when you install the Unity Hub and you open it for the first time, you're going to receive this screen that is asking you to log in because you need an account. Okay, so you're either going to sign in if you already have an account, or you're going to click create account and you're going to create your own account, which is exactly what I am going to do. And now that I created the account and confirmed my email and everything, it is time to log in into the Unity Hub. So we're going to sign in. Okay, it will already know we are logged in. So we're going to click open Unity Hub. And here you can see that it says that we need a license, an active license. So for this, we're going to agree. And that's it. We are good to go. Here, as you can see, it says that we have no project yet. That's true. We're going to create our project soon. But before we do that, we have to actually install the Unity game engine. So for this, we're going to go to the Installs tab, okay? And we're going to click Install Editor. Perfect. Now here, as you can see, there are multiple versions of the Unity game engine that you could install. Right? The one we're going to look for is the one that is in the official releases tab and the one that has the LTS tag. This means long-term support, and the one that says recommended version. Now don't worry about this number here. If it's 27 by the time you watch this video, maybe it's gonna be 30, 31, it doesn't matter. As long as it is recommended, you are good to go, all right? So we click install, and that will take a while because it's a little bit heavy, okay? And also, as you can see here, after you click install, they're gonna tell you that you can add modules to your installation. And this is important because Unity Game Engine, it does a lot of stuff, but you need extra things. For example, we're going to end up writing code. We have to write code, right? Because we have to program our game. So you need a code editor for that. And as you can see here, they are telling you that if you don't have one, they're going to install also Visual Studio Code. Now, if you are a developer, most likely you're going to have Visual Studio Code installed. So this is going to say installed here, okay? But if it isn't installed, then you're going to click a box like this one to select it. But in my case, because I already have code installed, then it doesn't show the box, okay? Now, as you can see here also, it says platforms. What does this mean? Here, you can choose what are the platforms that you want to export your game to. With Unity, when you make a Unity game, you can actually export that game to multiple platforms like Windows, macOS, Linux, iOS, Android, and others, okay? You want to export your game to Android? Then you need to add the Android build support module. If you want to export your game for iOS, you have to check this box. It would be a waste of space if Unity came with all these pre-installed. Instead, you can actually choose and say, no, I don't want to make an Android game. I am not making an iOS game. I am going to look for the WebGL build support because this one is the one we actually need to be able to build the game and export the game in the web because we want to export this game and put it on a website. So we have to select WebGL build support. Now, if you tomorrow change your mind and you decide that you also want to make an iOS game, then don't worry, you can also go in the settings and actually download the iOS build support tomorrow if you change your mind. So don't overthink anything here, okay? And don't try to install all the packages because that will take a lot of space in your hard drive. Okay, just install the things that you are for sure going to use. And what we are for sure going to use is the WebGL support, which is how we can export games to the web, all right? And if you want to, you can, of course, add the translations for Hangugo if you want. And here, if you want to as well, there is a documentation that you can download, and this is like offline documentation. So if you are on an airplane and you want to make a game and you want to look at the Unity documentation, you will click this box because this will give you offline documentation. It will download the documentation for you so you can develop Unity games from a airplane, a train, a boat, whatever you want. All right, so again, Visual Studio Code, and then WebGL build support, and we are golden. We click install. I will see you when this is done. Bye-bye. Once the download has been completed, we're going to go to projects, and here we're going to now create a new project. We're going to see a list of all the different templates we can get started with. These are like starting projects that you can use depending on what you are building. For example, if you were building something for AR, you will use this template. Something for VR, you will use this. If you were building something with multiplayer, you will use this template. In our case, we're going to be using the universal 2D template. You can then name it whatever you want over here. So you will do KIMCHI-RUN, it doesn't matter, whatever you want. And then here you will select what is the location where you want to save the game, all right? Here you're going to see your account. You don't have to connect it to Unity Cloud, like you can enable this or disable it, whatever. And we're gonna click Create Project, and that is going to create a 2D project in the editor that we downloaded. All right, that will take a while, so I will see you when it's done. Now that our project is opened, let's familiarize ourselves with what we have in this UI. So here we have the project tab, and this one basically shows you all the assets in your project. As you can see here, we already have a folder called packages, one called settings, one called scenes. We are not gonna touch the settings and packages. We are gonna touch the scenes folder because we're going to rename this scene to main scene. Now, what is a scene? A video game can be divided in multiple scenes. Like for example, the main menu can be one scene. The first level can be another scene. Level 2, another one. Loading scene, maybe settings screen. All those things are a scene, separated scene. In our case, because our game is not too complex, we're only gonna have one scene, okay? This part right here, the hierarchy, are all the game objects that are inside of your scene, okay? That's very easy to understand. As you can see here, by default, we have a main camera and a global light. So when you're making a video game, I want you to imagine that you are making like a movie, where literally there are cameras in the movie. And depending on where the camera is and what the camera records, that is what the audience will see. It is the same with the video game, okay? We need a camera because that is what the player will see, okay? And we need a light because our objects need to be seen. So we need to light our objects, all right? So in this case right now, our hierarchy just has these two things, okay? We're going to be adding more. Here we're going to add the player, we're going to add the enemies, we're going to add the backgrounds, all those things, right? So that is the hierarchy. Now here we have the inspector. The inspector is basically how you can configure all the components that your objects have. So for example, if you click on the main camera is a game object, and the main camera game object has a transform component that you can use to position the main camera wherever you want. It has a camera component that basically turns it into a camera, and it has a audio listener component, and it has a script. Now we're not going to touch these things, but just become familiar with the fact that we are going to select something from here, okay? And then we're going to configure the components that it has here, okay? A game object can have multiple components. Later you're going to see our player is going to have a script component to run some code. It is going to have a physics component, so we can make it jump. It is going to have a collider component, so it touches things and bumps into the enemies. So all those things are components, and one game object from here can have many components, all right? To get started building our game, I want you to go to this website, KIMCHI-RUN.xyz/assets.zip, okay? That is going to give you a .zip file called assets, and this file will contain all the assets that you need to make this game possible. Here we have all the food, the Bechu, building 1, 2, 3, 4, 5, multiple buildings. We have the backgrounds, we have the delivery addresses, we have Manu, Gochu, the golden Bechu, we have the ground, we have the harmonies, hearts, and we have the jumpers and the runners. We have everything we need, right? So what you're gonna do is you're going to go to assets, and here we're gonna create a new folder, and we're gonna call this folder sprites. Sprites basically means like the images we're gonna use in our game. You will see that term a lot. If you are making games, you will see the term sprites a lot. Now, what we're gonna do is we're going to drag and drop all our sprites here, okay? And now we're going to change a setting, because as you can see here, when I click on my player, you can see that my player is very not high definition. It doesn't look good. It looks very, very bad, okay? And the reason why this is happening is because actually Unity is trying to help me. Unity tries to make my images look not pixelated. But for example, if you look at the players, here is a very tiny image, but that's okay because we actually want it to be pixelated. If you zoom in, we actually want this look. We want the pixels to be visible because we're making like a retro looking kind of game. Okay, so we don't really want this sort of thing because Unity here is trying to help us, trying to make it look sort of optimized so the pixels don't show up. But as you can see, it looks very ugly. So we're gonna say that we don't want Unity's help. And for this, we're going to press Command A. Okay, use here Command A. All right, and that is going to select all our sprites. And here we're going to say that filter mode is going to be no filter. All right, and also here we're going to say that we don't want to compress our images, and we're going to click Apply. Okay, now after doing that, we can then come here and click on our player, and as you can see, now we can see the pixelated high definition. Now, Unity is not trying to help us at all, trying to make this look not pixelated because we are saying we actually want the pixels because we actually like pixels, okay? And that's it, we're done with the setup. Now it's time to create our backgrounds. That is the first thing. We have to create a sky background, then the buildings, and then we have to put the platform so the user can stand on it, so the player can stand on it. To create our platforms, we're going to go to our scene, we're going to do right click, and we are going to create a 3D object called a quad. And I know what you're thinking, why are we creating a 3D object when we are in a 2D game? Well, the quad is like a sheet of paper, literally, okay? It has a width, it has a height, but it is not thick at all, right? So here we have our quad, you can see it here, it's very tiny, very small. So we have our quad, we can resize our quad, but now if I enter 3D mode, as you can see, the quad disappears. Okay, why? Because the quad is like a sheet of paper. We cannot see it really well in the 3D space. I'm gonna enter 2D mode again, and now the quad is back there. So this is why we use a 3D object, even though we're making a 2D game. All right, let's get familiar with these controls right here. So this one is the view tool. Okay, and if you click on it, you can click and drag and move around your scene. By the way, this rectangle right here, this rectangle, that is the camera. So whatever is inside of the rectangle is going to be seen by the user, by the player. Okay, like if you're making a movie, whatever is recorded by the camera is going to show up in the movie. All right, so you can click on the view tool and you can just drag your scene. This one is the move tool. Okay, you can access it with the W key, and this one allows you to move your elements like this. All right, this one is the rotate tool, but in our case, we're not going to be using rotations, although you could. As you can see, we don't want 3D stuff, so we're going to do Control Z. We don't want any of those things. This one is the scale tool. So if I press on the quad and I use a scale, this allows you to scale it in this direction, horizontally and vertically. All right, and this one is the rect tool. And this one allows you to basically modify like this. Okay, easy to understand, right? And now this one is the transform tool that basically combines everything. So you can move it, you could rotate it if you want, and also you can scale it. All right, but we're not going to be using this because as you can see, things get too crazy. Now, if you ever don't like what you did, you can always come here and reset everything. You can reset the scale to be 1, the 1 in the y-axis, and the position to be 0, 0, 0, and it will stay in the center. So if we do this, as you can see, it's going to become a square again. All right, now of course, if you want to zoom in, just scroll in, scroll back, like very easy to understand, right? Okay, let's resize our quad and let's actually call it. So let's click on it, enter, and let's call it sky. Okay, and now here let's use the rect tool. Okay, and we're going to make it overflow the camera. To see a preview of what the camera is looking at, you can click here for the game tab and you can see what the camera is looking at. Okay, as you can see, the quad is overflowing the camera. If I do this, as you can see, the quad is not overflowing the camera. All right. Now, by the way, if for some reason you don't have this layout, you can just come here and you click layout and you click default, and that's it. There are many kinds of layouts, and you can, if you want to drag and drop tabs like this, but in the case that you make a mistake and you, for example, want to go back to what you had, just click default and you're good to go. Default will just reset everything. All right, let's resize this thing. Okay. Let's go all the way here and all the way until the end. All right, so this is going to be our sky. All right, now of course it's going to look better later. Now what we have to do is we're going to drag and drop the sky image into this quad. So we take the sky image, the sky sprite, and we do this. Boop, and that's it. We are done. That's how easy it is. Okay, so we just gave it a background. Done. Okay, now as you can see, this image is being stretched, right? Now, if you look at the image, okay, it's not that big, okay? But it is being stretched to basically fill the whole quad. And that is not what we want. What we actually want is we want to repeat this image multiple times in the quad because we're going to have an infinite scrolling background. That means the image has to be repeated many times, okay? We don't want it to be stretched like this. Right now, as you can see, it's being stretched. So what we do is we're going to click on sky. And actually, we're going to do the same thing with buildings also. So Command or Control select sky, buildings, and also the ground. All right. And we're going to come here and we're going to say wrap mode. And we want to do repeat. The reason why we want to do repeat is because we're going to repeat those images multiple times. We want to, again, create an infinite scrolling feeling. So the sky needs to be repeated. Right now, the sky is not being repeated. Right now, the sky is being stretched. So one image of the sky is stretching all the way from the beginning to the end of the quad to fill the whole thing. That is not what we want. So we're going to come here, we're going to do repeat, and we click apply. Okay, that didn't change things. But now what you will see is that the moment that you drag this image into your quad, there is a new folder in your sprites folder called materials. So what is a material? A material allows you to customize how the images are applied to your elements. And you can create many different kinds of materials. For example, if you were making a 3D game, something more advanced, and you have a coin, you can give the coin the image of a coin, maybe with something in the center that shows the face of the queen, whatever. Okay, but using materials, you can make that coin glow. You can make the coin metallic. Okay, so one thing is to have an image, which is what we have. We have an image of the sky. Another thing is to have a material. The material customizes how the image is applied, okay, in the quad or in whatever element you want. In our case, as you can see here, we are using one image of the sky to fill the quad, okay? And maybe that is not what we want. Maybe we want two images of the sky filling the quad. We can change that setting here, tiling. Okay, this allows us to specify how many images of the sky we want to use to fill the quad. Right now, one image of the sky is filling the quad in the horizontal direction, and one image of the sky is filling the quad in the vertical direction. Now let me show you what happens if I do 2, for example, or 3. As you can see now, the sky is not being stretched, or the image is not being stretched. Now we are using 3 images of the sky to fill the quad in the horizontal direction. And you could make it, if you wanted to, 3 by 3. So now as you can see here, we have 3 images of the sky filling the quad in the X, and 3 images of the sky filling the quad in the Y. But of course we don't want that, so we're gonna come here and say no. In the Y, we want 1 image of the sky, okay? And in the X, we are okay with maybe 2, and we're good to go. Just like that, now our image is not being stretched, okay? Perfect. Now, just as a spoiler, later, using code, okay, when the game is running, we are going to modify the offset right here. And this is going to give us the illusion of scrolling. Let me show you. I'm going to click and drag, and you will see what happens to my sky. Check it out. Look at what happens to my sky. If I click and drag, look at this. It becomes infinite sky, you see? I change the offset, but because we are repeating the image, it seems infinite. How cool is that? It's fantastic, no? All right, I'm gonna set it back to 0. And now it's time to create our buildings. So we're going to come here and we're going to duplicate this one, Command or Control D, and we say buildings. All right, and we're going to go to our sprites and we're going to take our buildings and we're going to drag it on top of buildings. All right, and we're going to move it like this. It doesn't look nice because if you actually look at this image, as you can see, the buildings are a PNG image that have transparency here, and Unity right now is not applying that transparency. Thankfully, we have materials, and we know what materials do. They let us customize how the image is applied to the quad. So we're going to go to Sprites, Materials, we click on the Buildings material that was created automatically for you, okay? And here in Surface Type, we're going to say Transparent, okay? Because we don't want it to be different. And as you can see, we're done. That's it. Finish. Look at this. So now it is transparent. How cool is that? Very, very easy to understand, no? All right. Now, using the rect, we can make our buildings maybe a little bit taller, like this, okay? But still, as you can see, they're being stretched, okay? So now we're going to, again, go to the material buildings, and here in tiling, we're going to change it. So how many images of buildings do you want to use to cover your quad in the horizontal axis? In my case, 2. I guess that looks nice. 1 is too stretched, I think 2, or maybe 1.5. And that is nice, look at that. That's looking good, no? Not bad, I like it, okay. And again, in the future, we're gonna come here, we're gonna do offset, and look at this. Scrolling buildings forever. How cool is that? Fantastic, awesome, all right. Next up, we're going to click on buildings, Command D, Control D, and we're gonna say ground, or platform, okay. We're going to resize that one, okay, because this one is going to be the platform. So we're going to go to sprites, we're going to touch our ground, and after selecting the new buildings that we duplicated, we're going to drop the ground there. All right. Now here, as you can see, we have a sort of tiny problem, and that is that the ground, as you can see, is behind the buildings, okay? It's because they're basically on top of each other, okay? And one way of changing this is coming here and modifying the position. So the one that has the higher number is going to go the furthest away. So for example, we can say sky, and here on the z-axis, which is depth, okay, we can say, let's say 100. Okay, then buildings can be 90, for example. And as you can see now, that shows us our platform. That is one way to modify this z-axis right here. Or another way is you can come here and disable the 2D view, and as you can see, we can now see how everything looks. Look at that. We have first our ground, then the buildings, you see, and then our sky. and it's O. Now in a 3D space, it's easier to understand, right? So you can do W, and then you can move them around if you want, but I think it's better. You just do 2D always, and you just mess around with this. I think that's better. So we do sky 100, ground is going to be 90, okay, and the platform is going to be 80. Okay, good. Now we have to do the same thing that we did with the rest for the material of the platform, because right now the platform is being stretched. Maybe it doesn't seem like it, and I guess you would be okay if you leave it like this, but we can also do tiling. So we're going to go to materials, ground, and here again, tiling, let's do 2 or 3. And as you can see here, the squares now are squares. If we do 1, they are rectangles, they are being stretched. We're gonna do 2, and we're good to go. And again, in the future, we're going to do this, modify the offset, and that is going to modify the background. How cool is that? Easy. Okay, so to take a look at how the user sees our game, we're going to do game here, and this is what the user is looking at. I think it's okay. I think it's fine. All right, we can maybe put this a little bit lower, maybe here. What does it look like? Okay, now we have to make the sky come a little bit lower as well. Maybe make it look like this. Maybe the sky could be using the rect tool, touch the sky, rect tool. Maybe a little bit like this. Okay, how are we looking? Yeah, that's not bad. That's good. You can modify it as much as you want. You can change the size. Maybe the platform is too big. You can also squash it a little bit. That is on you. You are the kingmaker here. You can do whatever you want. Okay? Now, one thing here is that, as you can see, because I put the sky down, we are now looking at nothing here. We are looking at emptiness because this is the background of the camera. A very easy trick for us is to change the background of the camera to be the same as the background of the sky. So we're going to select the main camera here. We're going to go to camera, and here, as you can see, we can see the background. We're going to press on this eyedrop. We're going to click on this background right here. Boom. So now, if the player looks at the game, this is how it looks. Fantastic. Now I should put my sky a little bit more down. So let me touch my sky and go down. Okay, perfect. I am going to leave it as it is, and we are now going to move on to the next part, and that is creating the code that is going to scroll those backgrounds forever to get an infinite scrolling feeling. Back in our assets folder, we're going to do right click. We're going to create a new folder. We're going to call it scripts. All right, we're going to enter scripts, and we're going to do right click, create a new mono behavior script. Okay, and we're going to call this background scroll, like that. All right, we're going to double click it, and that is going to open automatically. It should open automatically Visual Studio Code. All right, and if it's your first time opening any C# project and Unity project, you're going to get a message asking you if you want to install the Unity extension. You're going to say yes, because that extension is very, very useful. All right, okay, and we're done. So what do we have here? Here we have what is called a mono behavior class, okay, called background scroll. Here we are inheriting from mono behavior. This is how you inherit from classes in C#. Very easy to understand. If it was Python, you would do something like this, mono behavior like that. Maybe if it was TypeScript, you would do something like extends and then mono behavior like that. Very, very easy to understand. This is how we do inheritance. All right. Whenever you have something like a game object that you want to manipulate from your code, like right now we have a material that we want to manipulate from our code, we want to change the offset. Whenever you have that, you're going to be extending from mono behavior. Okay, cool. Now, what do we have right here? We have void start, void update. Void is what this method returns. So for example, if you were doing a calculator, you will do int plus like that, and you will receive A and you will receive B. Okay, easy to understand, right? This is the return type of the method. Now, they are already created for us, void start and void update. Okay, so what is void update? Void update is a method that, as you can see here, is called once per frame. So if your game is running at 300 frames per second, it is going to be called 300 times per second. Then we have start, and start is a method that is called once before the first execution of update. So in the start, we can do all the setup. And in update, we're going to maybe detect when the user is pressing the key. We're going to add force to the player so the player can jump. We're going to do all those things in update. All right. So again, start runs once before the first execution of update, and update runs once per frame. All right. Cool. The code we are about to write here is going to operate on the sky, buildings, and ground. So what we have to do is we have to give this script to the sky, buildings, and ground. The way we do this is we select sky, and we have many ways of doing this. One way is we come here, we do add component, and you can search for the name of your script, in our case, background scroll, okay, and that will add the script background scroll to sky. Another way is you select, for example, buildings, and you drag and drop from here all the way to buildings, all right? And as you can see, buildings has the background scroll script. Another way is to just click on platform, for example, and just drag and drop it like this, the easiest one, all right? But the point is, make sure that you give the background scroll to platform, buildings, and sky. Most of the time, when people have mistakes in Unity, the biggest mistake that is super annoying to find is that you write the code and you press play and you play your game and you don't see nothing happen. You're like, why? And you try to find out what's wrong, and then you realize, oh, I didn't give a script to my game object. That is crazy. Okay. Now, what we want to do next is we want to make this background scroll script customizable. We want to be able to customize the speed at which our textures are going to scroll. We want the sky to scroll slower, the buildings to scroll faster, and the platform to scroll a little bit faster than both the sky and the buildings. For this, all we have to do is come to our class and expose a public property. So we say public and then the type, let's do float, and we're going to say scroll speed, for example. We do this. Just by doing that, you're going to save, you're going to go back to Unity, the project is going to reload, and then you're going to see that now here you can pass the scroll speed, which is super cool. You can pass the scroll speed here, like that. Fantastic, no? Super nice. Now, if you want to customize how it looks, you can, for example, do an attribute, which is something that C# has, and you can say header, and here you can do settings. Okay, you save that. And maybe here you're going to do also tooltip attribute, and you can explain what this setting is. How fast should the texture scroll? For example, okay, you don't have to do this, I just want to show you because I think it's cool. So you go back to Unity, it is going to reload, and now as you can see, we are in settings, and we have a tooltip that if we put the mouse on top, we can see the explanation, and we have a settings header. It's pretty cool. Okay. Another thing that we need, or our script needs, is our script needs access to the component. This is a component. All these are components. Our script needs access to the component that is rendering the texture, that is rendering the material. Okay? Because the material exists, but there is a component inside of our sky, building, and platform that is in charge of rendering the material. Rendering in this context means displaying it on the screen. That component is the mesh renderer because it renders textures, it renders materials. As you can see here, our material is being rendered by the mesh render. Don't believe me? Unclick this here, and as you can see, your platform is gone. So our script needs access to this mesh renderer. We need to give this mesh renderer to our script. Thankfully, it is very easy to do so. So now we're going to create another section, okay? And let's call this one references, okay? And here we're gonna say public. And what do we want? We want a mesh renderer. And we're gonna call this mesh renderer, for example, okay? And now if I save and we go back to Unity, you will see that your script now is asking for a mesh renderer. If you try to, for example, drag the mesh collider, it's not going to work. You see, if you try to, for example, drag the quad mesh filter, it's not going to work. But if you drag and drop the renderer, it works. How cool is that? Okay, so this is how you can give components to your scripts. Later, we're going to be using this a lot. For example, when we have a player, we're going to give a player some audio clips. So we're going to drag and drop some audio clips. So when the player jumps, we can play that audio clip. Okay, we're going to do this a lot. Now, again, here, make sure that you do this for every single object that is using your script because it's very easy to forget. We're gonna go to buildings, okay? And here, as you can see, it says none. So we have to do mesh renderer and we drag. We have to go to sky. Here again, mesh renderer and we drag, boom. Okay, and we're good to go. Let's change the speed to 1 and buildings is gonna go faster. So speed to 2, okay? And platform, let's do speed to 3. Okay, these values are not really good. I mean, as you will see very soon, we're gonna have to change them, but that will do the work for now. Okay, so we're good to go. Now our script has access to the speed, how fast we want to scroll, and the mesh renderer. Very easy. Now all we have to do is move the texture, change the offset of the texture like I showed you before. Let me give you one last example. Look at the sky. We're going to enter the material and we're going to say offset here. Okay, and we're going to change the X value. Okay, that is what we're going to do. Fantastic. So let's go. Where should that happen? Should that happen on the start? Should it happen once? Or should it happen often? Once or often? Correct, it should happen on the update. So here we're going to say mesh renderer, okay, and we're going to say material, we're going to say main texture offset, and here we're going to change the offset. And because we are doing this in the update method, that means that this is going to happen on every frame. That is not as good as it sounds, as you will see very soon. It's gonna happen too fast, we have to slow it down later. But before we do that, look at this. The main texture offset is a type of vector 2. Vector 2 is basically a thing that holds two values, an X value and a Y value. A vector 2 is like a coordinate in a 2D space. We also have a vector 3. You will see that also a lot. And vector 3 holds three values, X, Y, and Z. For example, as you can see here, this is obviously a vector 2, X and Y values. And for example, the location of our sky is a vector 3, X, Y, and Z. Easy to understand. Okay, so what we have to do here is we have to say vector 2. So we have to say vector 2, new vector 2. And we are going to move the offset in the x-axis by the speed, and that will be the scroll speed. And we don't want to move it in the y-axis, so we're gonna say 0, like that. Okay, done. Now, if we do this, we're going to set the texture offset to this new vector, x and y, and we're not gonna see anything new. Why? Because we are doing equals. So this means that this assignment will happen over and over and over and over again, but the result will be the same. We don't want to do that. Instead, we want to do plus equals. And that means we're gonna take the current vector 2 and we're going to add a new vector 2. And on the next frame, because this runs once per frame, we take the current vector 2 and we add another vector 2, right? We're going to save that. We're going to come here. It is going to reload. And now if we press play, that is actually going to run our game and it's going to run the code. And it looks like it doesn't work. Weird. Let's see. We're going to click on sky, for example. We're going to click on this material and we're going to go down. And as you can see, it is working. The offset is changing, but it's changing incredibly quick. As you can see, it's already 16,000 on the x-axis. It's changing incredibly quick, so we don't see it running because it's happening too quick. Why is this happening? Well, this is happening because, again, the update method runs on every frame. And if you look at your game here, this is running at 400, almost 500 frames per second. That means that we are increasing the texture offset 500 times per second. And we don't want that because we don't want to depend on frame speed. We don't want that. The reason why is because maybe right now our game is running at 600 frames per second. That means that the background is going to scroll incredibly quick. If we have a frame drop because maybe the memory is full, then the background is going to start scrolling slower. Or if the user maybe is playing our game in a mobile device or a weaker computer, a weaker machine, and maybe their game runs at 30 frames per second, that will make our scrolling look slower. So we don't want that. Instead, what we want to do is we want to move this main texture offset, but we want to move it per second, not per frame. This is always going to be running per frame. There is nothing we can do about it, okay? But what we could do here is we can do this, that time, that delta time. Let me explain what this does. Time, that delta time, is the interval in seconds from the last frame to the current one. By multiplying the speed by time, that delta time, we are going to accomplish our goal to move the texture offset by this speed per second. Okay, so let's do a simulation to understand time, that delta time. So imagine that my goal in life is to move my texture offset 10 units per second. Very important, 10 units per second. That's what I want, imagine. So I want 10 units per second. Okay, now imagine that the game is running at, let's say, 2 frames per second. 2 frames per second. Okay, so if we do this, what's gonna happen? Is my goal going to be accomplished? No. The reason why is because if we are at 2 frames per second, that means that per second, this is going to run twice. So that means that we are gonna end up moving the texture by 20 units per second. That is not what I want. Also, I cannot depend on this math because the 2 frames per second are not guaranteed. Maybe I'm gonna go up to 3, up to 4, down to 1. So I cannot always be sure I'm gonna be running at 2 frames per second. So instead, so I don't depend on frames, what I can do is I can come here and I can multiply by time that delta time. And again, time that delta time is the interval in seconds from the last frame to the current one. It tells me how much time has passed since the last frame. Now, if we are running at 2 frames per second, that means that every frame is basically 0.5 seconds. So time that delta time will tell me that the distance in time, in seconds, between the previous frame and this frame is 0.5. So this accomplishes my goal because I do 10 times 0.5, that gives me a 5, and this runs in the first frame. And then in the second frame, because we are running at 2 frames per second, then this runs again, and I accomplish my goal to move it 10 units per second. Okay? So this is why we multiply by time that delta time. Okay? This delta time again tells us how much time has passed in seconds from the previous frame. All right? So now, as you will see, we can come here and do scroll speed again. I will delete this. All right, and let's go back here. We press play. And let's see. There it is. It's looking better. Now, if you look at the material, you can see the material is running, it's moving, and you can see that we are increasing the offset, but not by so much, by little, because we want to increase it not by a lot, by little bit at a time. Fantastic. Now, while your game is running, you can actually modify what you wrote here on the script. So for example, right now the sky seems too fast. So let's do the sky 0.1 just to test how it looks. I think that's way better. Okay, now we're gonna go to the buildings. Okay, and we can modify it also here, maybe 0.2. Yep, that's not bad. And then platform, and then this one is too fast. This one should be a 0.8 maybe to give the illusion of running. I think that's fine. So remember these values. Sky is a 1 at 0.1, building 0.2, platform 0.8. I'm saying remember this because the moment the game stops, they're going to go back to what it was before. So platform 0.8, okay, sky 0.1, and platform 0.2. You can change this if you want. I mean, you don't have to follow my values. And we are done. 0.2. We are done, everybody. Good job. We are now have a scrolling background. Now what we have to do is we have to put the player standing up here, and the player is not gonna really run. But because everything is scrolling, we're giving the illusion of movement, which is super cool. Now it's time to include our player, our runner. We're gonna put it right here. Okay, so what we're going to do is we're going to go to our assets, sprites, and then you're going to take your player run. And as you can see here, Unity is so smart that Unity realizes that this is an animation. Look at that beauty. Unity knows that these are all separate images. Player run 0, 1, 2, 3. It's very cool, very, very cool. Now, sometimes maybe if you're making a game and you download assets from the internet, sometimes Unity won't be able to cut your animation as well as it should. So you can actually just come here and click Open Sprite Editor. And as you can see here, you can tell Unity when one frame of the animation starts and one ends. And you can cut them, you can move them if you want. It's pretty cool. It's pretty nice. All right, cool. So I'm gonna close this because we're not gonna actually modify this at all. Okay, and now all we have to do is we have to select each one of them separately. Okay, and we're going to drag them here. Boop. Okay, and as you can see here, Unity knows that it should create an animation, which is super cool. So we're going to tell it where to put the animation. That is going to be on assets, and let's create a new folder called animations. All right, and the name of the animation will be player run, or like this, player run. Done. Save. Perfect. Now, as you can see, our player is very small. It's very, very tiny. You can change that if you want by scaling it here. Okay, but an easier way is to take a click on the player run. Okay, and here you can change the pixels per unit. Okay, so this basically says how many pixels will Unity put inside of one scale unit. So for example, here, if you look at your player, scale is 1 by 1. Okay, so 100 pixels per unit means that Unity is using 100 pixels of the image, okay, to fit in one unit. Now that means that the pixels don't have to be too big because there are 100 of them. But if, for example, we do 30, we're telling Unity to only use 30 pixels per unit. That means the pixels have to be bigger. Makes sense, right? If you do 100, you're saying you have 100 pixels to spend. If you do 30, you say you have 30 pixels to spend. That means that if you want to fill the same surface with only 30 pixels, the image has to be bigger. So we're going to select our player run, also player jump. We discard here, player run, player jump, delivery, and harmony as well. We're going to say 40 or 30. We're gonna make them all the same, and then we click apply. And as you can see, our runner has grown. Fantastic. Now, without doing anything else, we're going to press play. And look at that beauty. How cool is that? It just works. It just works. Fantastic, no? Absolutely amazing. If you want to modify the size, maybe you don't like the 30, maybe you want to make it smaller, you can go for 20. The lower the number, the bigger it's going to be. Apply, there is the size. It depends on you. Okay, it's easier to modify here, or again, you can just scale it using the tools we saw before, the same way that we scaled our quad. Well, this looks good. All right, so we have our player done. Now, what we need to do is we need to make our player be like a real object, like have physics. We want it to have mass. The reason why is because we want to make it jump. That means we have to add force to the player so it jumps. But also we want gravity to operate in our player so it falls down. So it's heavy. We want all those things. And it is very easy to do those things. We're going to come here. We're going to rename this to player. All right. And we're going to add a component called a rigid body 2D because you are making a 2D game. So you will use 2D versions of everything. So rigid body 2D. Just by doing this, now your player is going to have a body that is going to be subject to the laws of physics. So the moment that you press play here, look at that. We're falling, boy. Look at that, we're falling. And the player is falling here. You see, it will fall forever. If we don't stop the game, it will fall forever. How cool is that? The moment we press play, the player falls. Immediately, we just get gravity out of the box. It's so cool. Look at the player. Bye-bye, boy. How cool is that? Sweet, no? So now the player is falling. But what we want to do is we want the player to fall and maybe stop in the ground. We want to stop it here in the platform. Okay? So what is that we want? What we want is a collider. That is called a collider. Okay, when you want to make your objects bump into each other, what you're looking for is a collider to detect collisions. Okay, so what we have to do is we have to take our player. We're gonna come here and another component. We're going to find a box collider 2D. We have many kinds of colliders. We're gonna see some of them later. Okay, but they all have a 2D version. So we're gonna say box collider 2D. Boom. Okay. We do this, and as you can see now, the player has like a green box. See? This green box represents basically the bounds of the collider. Now, if we press play again, the player is going to what? Fall. It's going to keep falling. Why? Because it's colliding with nothing. It has a collider, but it's colliding with nothing. What we have to do now is we have to click our platform, okay? And this platform already has a mesh collider because it's a 3D object. We're going to remove that here. Okay, and we're going to add a box collider 2D. All right, so now all we have to do is press play, and guess what's gonna happen? Look at that. Now the player is not falling forever. Why? Because now the collider of the player is colliding with the platform. How cool is that? If you want to, you can modify the bounds of the collider. You can just press here, click. Okay, and as you can see, you can modify the bounds and you can say that maybe the collider starts here. Okay, so now the player is going to fall all the way until the collider bounce. And this is your choice. You can make it whatever you want. If you like the player standing here at the top or a little bit in the ground, that is your choice. So you press play, and as you will see, the player is gonna go a little bit lower now. And I think that's fine. I like it. It's fantastic. Okay? Cool. So now our player is colliding with something. Our player has physics. Now all we have to do is detect when the user presses the space key, and we're gonna give a force to the player, so the player jumps. All right, so for this, we're going to go to scripts, right click, create new mono behavior script, call this the player. Okay, we're going to double click that. We're going to open it. Please don't forget, you need to give the script to your player. So select the player, and we are going to just drag and drop this thing here at the bottom. Okay, so now as you can see, we have a player script. And now here in our player script, we're going to have a header called settings. I like doing it like this. You don't have to follow if you want. And we're going to say public float. And here we're going to pass the jump force. Okay. The reason why we pass the jump force is because I want to be able to customize it from outside. I'm going to be testing what force is good, how much force is good. All right. Now we also need a reference. So I was going to say references here. Remember, you don't have to do this. I just like to make it tidy. And we need a reference to what? We need a reference to the rigid body 2D. The reason why is because we want to be able to add a force to this body. We want to be able to modify the linear velocity of this body. This is the body that gives the player physics and makes it subject to gravity. And as you can see here, it gives it mass, and you can have damping, gravity scale. It's pretty nice. Okay, so again, we need a rigid body 2D. So here we can say public. We want a rigid body 2D, and we can call this the player rigid body. All right, we're gonna save that, and let's go back to Unity. It's gonna reload. And now here I'm gonna set the jump force to 10, and I'm going to drag and drop the rigid body 2D. Fantastic, cool. Now, we're not gonna do anything at the start for now. We're going to do it on the update. Here in the update, we're going to detect when the user is pressing the space key, okay? And it has to happen in the update because this, again, is run every frame. So if we are running at 400 frames per second, we are going to be checking 400 times per second if the user presses the space key. To do this, we're gonna say if, we're gonna say input, which is a class to get the input from the user. And we are going to use the method getKeyDown, which returns true when the user starts pressing down the key that we want. And the key that we want is key code that space. And we're done, okay? Now here, what we can do to move our player are two things. Number one, we can increase the linear velocity on the X and Y axis if that's what we want, or we can add an impulse force. We're gonna do both, and I'll show you how easy it is. We're gonna say player rigid body. We're gonna say linear velocity on X and on Y, as you can see, pretty cool. So you can say on X, let's give it a linear velocity of 10. And let's do the same thing here on Y, okay? And we do 20, for example, okay? This is one way of doing it, okay? So let's come here, it's gonna reload. We press play. And as you can see, the player falls. Now we press space, and look at that. We gave it a very big velocity. Somewhere over the rainbow is our player, there it is. All right, that was a lot of force. Rather than linear velocity, we can also come here and do add force. Okay, and here we have to pass a vector to, okay, of the force, and then the type of force. We can also do add force in the x-axis if you want to add a force on the horizontal axis, or in the vertical axis, which is exactly what we want. We want to add a force on the vertical axis because our player is not going to move in the horizontal axis. That is an illusion. The player is always static in the horizontal axis. It's never going to move, okay? So how much force do we want to give it? We want to give it this one, the jump force. So let's do jump force, okay? And then the type of force, okay? And the type of force has to be impulse, okay? It adds an instant force to the player, okay? And we're done. So now we come here, we wait, and then we press play, and let's go. Yeah, look at that. We add force in the vertical axis. Cool. Now, of course, this looks like the player is a little bit like on the moon. Gravity doesn't apply. No worries, we can come to the rigid body, and here maybe we increase the gravity scale to 2.5, so the player feels a little bit heavier, and you can play with this a lot. We can play with these values a lot. Look at that. Hey, that's better. As you can see now, it falls quicker. Cool. But if the player is heavier, we need more jumping force. So let's change that to 15. All right, and off camera, I'm going to be tweaking this until I'm happy with the jump. For now, just be happy that we have a jump. And yeah, I think this is okay. What do you think? This is fine. Okay, maybe a little bit less force. Let's go for a nice 12. And we're done. Okay, and that's it, perfect. I like this jump, it's good enough. Okay, the problem that we have here is that now, as you can see here, I can keep jumping forever. Just giving force and force and force to my player. And I don't want that. I want to be able to jump once, okay, not twice. So what we're going to do is we're going to create a private property here called isGrounded. That's gonna be a Boolean, okay, and it's gonna be called isGrounded, like this. And by default, it is going to be true. We're gonna start grounded. And now here we're gonna check if the user is pressing the down key space and we are grounded, then we're going to let the player jump. And we're gonna say isGrounded equals false. But now here we have a problem, and that problem is that I can jump the first time, okay, and I cannot jump ever again. And that's happening because we are never setting isGrounded to true, ever. It's always gonna be false after the first jump. What I would like to do is I would like to detect when the player collides with the platform. When that happens, when there is a collision between both of them, I want to be able to set isGrounded back to true. Okay, now thankfully there is a method just for that. This is a method that will be called automatically in your player when the player collides with another collider. Here it is. On collision enter 2D happens when an incoming collider makes contact with this collider, with the player's collider. And here you get information about the collision that just happened. All we have to do is implement this method and we are good to go. So we're gonna come here and do void on collision enter 2D. Very important, it needs to be named this way, okay? Very important. And here we're going to get information about the collision 2D that just happened. Collision. Okay. And the cool thing is that here we're going to know what is the object that collided with our player. We're gonna say if collision.gameObject.name equals, and what is the name of this one? Is called platform. So if it's equals to platform, that means we collided with the platform. Super cool, no? We get notified when there is a collision and we know who is the object that collided with us. So cool. So when we collide with the platform, we say isGrounded is equals to true. Okay, and we are good to go. So we come here, I jump once and it works. I jump twice and it works. I will try to do double jump. It doesn't work. It doesn't work. Fantastic. Fantastic. This is exactly what I want. Awesome. Sweet. Good job, everybody. We are done. And that's it. We now have a player that is jumping and we are detecting collisions with the ground. So we know when the player has actually fallen to the ground. How cool is that? Fantastic. It was so easy. So easy. All we need is the rigid body. So we can add force to the rigid body. We check for the key that is pressed and we check that we are grounded. Then we set isGrounded false. And then when we collide, we check that if we collided with the platform, then isGrounded is true. And we're done. Sweet. Next up, we need to do the jumping animation, because if you go to your sprites, as you can see here, there is a jumping animation. Actually, there is a jumping animation and there is a landing animation. We're going to learn how to make both of them. This one and this one. For the jumping animation, you're going to click on your player jump asset and you're going to make sure that the pixels per unit in the player jump and the player run are the same, 20 and 20, all right? Next, you're going to click on your player. Okay, let's go to scene, click on your player, and you're going to click on window and then animation, and we're going to go to animation here. And here we can see the animation of our player. You can see it go there. You can actually modify it if you want. You can make it faster, slower, whatever, okay? What we are going to do is we're going to click here and we're going to create a new clip, okay? A new animation. We're gonna call this the player jump. Player jump. Okay, so we save that, not here in assets and then animations, player jump, perfect. And as you can see, we don't have anything in that animation yet. That's fine. we're going to come here, we're going to press the arrow, and we're going to select the keyframes that make the player animation for jumping. And that is going to be this one, and this one. The rest are going to be for landing. That will be later, okay? So we're going to drag these things here, okay? And we're going to make the samples be the same as the player run. 12, and here we're gonna say 12. All right, and now we have the player jumping animation. We can preview it if we want here. You can press play. This is the player jump. Now, of course, it's too quick, and later we're going to make it better. Now we're gonna press pause, and then we're gonna create a new clip, okay? And that is going to be player, and that will be landing, or player land. We're gonna click save. Okay, now we're going to come here. We're going to select the keyframes that make up the land animation. We're going to drag and drop them here. Samples are going to be 12, and that is going to be the land animation, and this is how it's going to look. Now what we have to do is we have to make a transition between animations, because by default we are running. Then when we jump, we want to be jumping, and when we touch the ground, we want to play the landing animation. Okay, so for this we're going to click on the player, okay, and we're going to do window, again animation, and now we're going to go to the animator. All right, and as you can see here, we have our animations: player jump, player land, and player run. Okay, now the entry is the starting point of our player, and as you can see, it will immediately go to player run. If we play our game, you will see that player run is the only thing that is actually going to be running. You click on animator here, as you can see, player run. That's the only thing that is run. Okay, we want to make a transition between player run to player jump, and then from jump to land, and then from land back to running. Okay, so the way we're going to do this is we are going to do right click in player run, make transition, go to player jump. Then right click in player jump, make transition, player land. Right click in player land, make transition, player run. Done. All right, easy to understand. Now, if we press play, you're going to see your player dancing very funnily, and if you click on animator, you will see that all the transitions are basically playing after one another. This is not what we want. We want to have more control over the animations. We want the animation player jump to play only when we are jumping, and landing when we have landed. We don't want them to play one after the other, okay? So to disable this behavior, we're going to click on this connection right here, and we're going to click has exit time. We're going to say no. And here also has exit time, and we're going to say no. Exit time means that when the animation finishes playing, the next one will automatically play. This is not what we want. When player run finishes playing, we want player run to repeat. We don't want player run to automatically move to player jump. And when player jump finishes playing, we don't want it to go immediately to landing. We want to have control over when that happens. Now, as you can see here, this connection, we are going to leave the has exit time enabled, because when player lands, we want to play the landing animation, and then we want to just go back to running. So this one, we're going to leave has exit time selected. Finally, we're going to click on the arrows again, and we're going to open the settings, and here we're going to unclick, and we're going to say 0, 0, 0. What we are doing here is we're saying that we don't want any transition between our animations. Transitions basically allow you to say something like play animation B when animation A is 90% completed. They allow you to sort of overlap animation, and we don't want that, all right? So none of them should have any sort of transition duration. And the last one, this one, from player land to player run, should have an exit time. Cool. But now we have an error here in the console, and that is because Unity doesn't know when player run should go to player jump. We disabled exit time, which means that we are now in control of when that change happens, but we haven't specified when the change should happen. For this, we have parameters here. Parameters allow you to basically create sort of triggers or conditions that when they are met, when they are true, there will be a transition from player run to jump, for example. So what we're gonna do, and we can use floats, integers, booleans, triggers, we're going to use integer, okay? We're gonna say state, okay? So right now here, by default, the state will be 0, okay? And I'm going to press this connection, and I'm going to add a new condition. And I'm going to say that when state is equals to 1, that is when I want player run to go to player jump. I'm gonna click the second arrow, this one right here, and I will say again, new condition, that when state is equals to 2, I want to go from player jump to player land. And that's it. To go from player land to player run, we don't have a condition because player land has exit time, which means that when player land finishes, we're going to immediately go to player run. Okay? Sweet. So now let's press play. And as you will see, we're going to stay forever in player jump. You see, we are forever in player jump. I'm going to drag my animator here to the side so we can see what's going on. Okay? As you can see, we are in player jump. This is my player. Okay, fantastic. Now let's go and change the state. So state is going to be equals to 1. As you can see, state is now equals to 1, so we stay in player jump. Look at that. Now player jump is being repeated over and over again. We don't want that. We're gonna change it later. Now we're gonna say 2. As you can see, we landed and then we went to player run again. Again, 1, 2, 2, landed and went to running. One more time. 1, we're jumping. Then 2, we're landing, and then we went back to running when we finished landing. And that's it. Pretty easy, and it works very well. Okay, perfect. Now, as you saw, the animations are, maybe some of them are repeating, and we don't want that. So what we're gonna do is we're gonna say player jump and player land. We don't want them to repeat when they are over. Okay, we want them to be just run one time. So for this, we go to animations, we select player jump, player land, and we remove this loop time. Bye-bye. So now when player jump finishes, it's going to just finish. It's going to stay in the last keyframe until we change the animation. We want player run to be looping, so don't modify that because looping basically means running forever. That is what we want. Okay, cool. Now it's time to go back to our player and we're going to modify the script a little bit because now we need access to the animator. So we can, using code, do what we just did using our keyboard. We have to do 1 and 2, okay, depending on what the player is doing, okay? So let's go to our Visual Studio Code, and here again, like I said, we need access to what? We need access to the animator. All right, so here, let's do public. We're gonna say animator, okay, and this is gonna be the player animator. Fantastic. We're gonna save that, come back here, it will reload, and we're now going to drag and drop animator here. Okay, so animator, drag and drop, boom, done. Now we're going to go to our jumping logic, and here we are going to say player animator that we're gonna set integer, okay, and we have to say the name of the integer. So remember, the name of your integer is state. Make sure it is the same. Please make sure it is the same. Here, parameter, state. So you come here and you say state. Okay, and the value is going to be what? When we jump, the value has to be 1. Right? We wrote this condition here. Click condition. State equals to 1. That is when this state transition will happen. Okay. So state is equals to 1. Perfect. And then when we collide with the ground and we are grounded, we're going to say set integer state equals to 2. And we're done. A problem that we will have here, I believe, is that the moment the game starts, our player is colliding with the platform to start running. So the moment the game starts, we're going to be setting this state. That is not what I want. I only want to set this state if we are jumping. So for this, I'm gonna come here, I will say if we are jumping, which means if we are not grounded, then I want to set the state to 2 when the player collides with the platform. Because again, this code will run the moment the game begins, because the moment the game begins, the user is colliding with the platform. Okay, so I don't want to set the state to 2 when the user just started the game. I only want to do that when the user has already jumped, and that's what we are doing here. All right, so we save, go back to Unity, and let's press play on this bad boy. All right, so now I jump. As you can see, it's working, and landing animation works. Look at that beauty. Jumping, landing animation works. As you can see, as I jump, there is a point where the animation stops because it finishes, but we are in jumping frame, and then boom, we land. Fantastic. You could change the speed of the animation. You can go to player land, for example, and as you can see here, this is the speed. You can maybe make it slower, 0.5, to see your player landing. Okay, and also if you want to slow down your game a little bit, because maybe you want to see it in slow motion, you're going to click edit, project settings, then here you're going to change the time scale to maybe 0.5. Time scale by default is 1, which is like normal time. and you can maybe accelerate your game and everything on it. Literally, you increase the time scale, everything will become faster, all the physics and everything, or you can slow it down. 0.5 just for now, because I want us to see the jumping and see if it actually works well. So as you can see, we are in very slow motion. I will press click. As you can see, we jump and then we land. Fantastic. Look at that. We jump and then we land. Awesome. Sweet. Perfect. Now there is one thing I would like to fix, and that is in our animations right here. Let's touch the player, window, animation. Okay, we're going to focus on the player real quick. And you will see something a little bit weird, and that is in the player land. Let's look frame per frame. So at the end, this frame, as you can see, look at the feet of the user, of the player. The player lands here, but then it goes up a little bit and it goes down again. You see, there is like a space. Okay, now this is happening because of the way that Unity cut our sprite. Okay, what I would like to do is I don't want to have any space at the bottom of my sprite. So we're going to go to sprites. We're going to go to player jump. We're going to do a sprite editor. And here, as you can see, there is no space at the top. So the sprite shrinks. Okay, we do that and we are good to go. So now the player is not going to look like it's shrinking. Okay, let's go. Jump. Tuk, 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 tuk. Oh, fantastic. You land, tuk, 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 and you keep running. Yes. All right. And we're done. Make sure that you change the time settings, okay? Edit, project settings, and go back to 1. Okay, you do not want to keep it low. Okay, and now it will look way better when it's quick. And that's it. We're done. We now have our player running, our player jumping, and our player landing. Fantastic. You can modify the speed of the animation to make it look however you want. Sweet. Now it's time to start scrolling our enemies. And we have to start scrolling the food, and we have to start scrolling the buildings. We're gonna get started scrolling the buildings. We want to create a building here. We wanna create the buildings here off camera. We want to scroll the building all the way until the end, and when the building reaches the end and is off camera again, we want to destroy the building. And that is going to be the same logic we're going to use for the enemies and for the food. Literally the same. We want to create the enemy, scroll the enemy, and then destroy the enemy when it's off camera. So it's the same logic. We're going to take this first building and we're going to drag and drop it here in our scene. Okay, and there it is. Very tiny, very small. Okay, to make it bigger, we're going to actually take all the buildings, so they should be bigger, and we're going to change the pixels per unit again. Let's do a nice 40, see if that's good enough. Nope, should be bigger. Let's do 20. 20, apply. Oh, that's too big, bro. Okay, 25, sorry, and go. Okay, perfect. So there we go. Now, as you can see, when I drop buildings, they are sort of anchored in the center, you see? So whenever I drop another building here, as you can see, the anchor is in the center. You see, the point is in the center. Now, this is not gonna work for us because the buildings all have different height. So we don't want to get them from the center. We want to actually be able to move them from the bottom because we have to anchor them to the floor, okay? So what we're gonna do is we're gonna select all these buildings, building 1, 2, 3, 4, and 5. We're going to go to sprite mode. We're gonna say single, and we're going to say that the pivot or the anchor is in the bottom, okay? And we're going to press apply, boom, okay? So now we're going to delete these two, okay? And we're going to add it again. And now, as you can see, the anchor is at the bottom. You see, it used to be at the center. It is at the bottom. We want this because we want to be able to position them from their bottom, from here. Not from the center, but from here, from the floor, all right? We want their point of reference to be the floor. Cool? Cool. Okay, so let's play with this building only with this building. And let's first create two scripts. One is the script that is going to move this building from here to here. And another one is going to be the script that is going to destroy the building, okay, when the building reaches maybe this part of the game, this area off camera. The reason we do that is because we don't want to keep those game objects alive, taking memory when the user cannot see them, okay? Cool. So we need a creator script, a spawner, it's called a spawner, we're gonna do it later, that creates the building. We need a mover script that moves the building, or the enemy, or the food, and then a destroyer script that destroys the building, okay? Or the enemy, or the food. So we're gonna come to scripts, we're gonna do right click, we're gonna create a new mono behavior script, we're gonna call this one the mover, okay? And we are going to take our building, our first building, and we're going to give it that script, the mover script, okay? We're also going to create a new mono behavior script, and we're gonna call it destroyer, okay? And we're going to take that same script and we're going to give it to our building again. And this is the cool thing about how Unity works, that one building or one object could have many different scripts, which is exactly what we want because we want to reuse destroyer and mover everywhere. Okay, so we're going to move it here. Perfect, so we have a mover and a destroyer. Cool, so let's put our building here. Perfect, and now let's go to our Visual Studio Code and let's open our mover. Perfect. What we want is we want to get the speed, how fast we want to move this element. So we're gonna say header, let's do settings, okay? We're gonna say public float move speed, all right? And we don't do anything at the start, we're going to do it at the update. And how do we want to move this element? Well, actually, it will be very easy. All we have to do is change the position in the x-axis, like this. Super simple. All game objects in Unity, they have a transform. As you can see, I can disable this one, but I cannot disable the transform. So all we have to do is move this, like that, and we're good to go. We just move it. It's easy. Here in our mover script, we're going to do something that we haven't done before and something we didn't know, and that is that we have a direct shortcut from our script, from this script, we have a direct shortcut from this script to the transform of the game object. And all we have to do is do this, transform. And this will give us, as you can see here, this is the transform attached to this game object, like that. We don't have to ask for it, it's a direct link. How cool is that? Fantastic. So now all we have to do is say transform that, and we're gonna say position, and we're gonna do plus equals to, because it's the same as when we scroll the background, we do plus equals to, all right? And here we're going to go to the left, and this is going to be a vector 3, because here we have X, Y, and Z, okay? So we're gonna say vector 3, we're gonna say left. And this, my friends, right here is a shortcut, okay? You could type it like this, or you can just do vector 3 that left, same. Okay, we're going to multiply that by the move speed, and we're going to multiply that by the time, that delta time, because we want to do it per second, not per frame. Okay, and here what you're basically doing is if the move speed, let's say, is 10, here you're multiplying minus 1 times 10, 0 times 10, 0 times 10. Okay, good, and we're done. Now don't forget to give it a speed here, move speed. Actually, we can give it a default speed, like 1F, for example. We do F because it's float, okay? So here we can change it to something like 2, let's say, and see how fast it should go. Now, of course, later we're gonna actually fix the speed. We're gonna make everything move the same, okay? And let's see if it works. Yeah, it works, look at that. Perfect, done. Oh no, our building is covering our player. So let's give our player a maybe minus 10 on the z-axis, and let's give our main camera, maybe let's give it a minus 50. All right, perfect. So now let's play again and see if everything works. Okay, like I said before, later we're going to synchronize the movement between the store, the shop, and the platform, okay? Because that is the whole point of the game. Things will get quicker, but they all have to move at the same time. So the store and the platform and the enemies and the food, they're all going to move at the same speed. Because right now it looks like the platform is scrolling faster than the shop, but that will be later. All right, so now it works. Perfect, and now let's work on the destroyer script. The destroyer script is going to be incredibly easy. All we have to do is get the transform position X. So we say if transform position that X, okay, is less than minus 15, I would say, yeah, minus 15 over here, then we're going to destroy that game object. So if you are less than 15, we're going to destroy the game object, and all you have to do literally is do destroy, that's a function, and then you will do game object. And just like we have a shortcut for the transform, there is a shortcut for the game object that references the game object that is attached to this script. All right, and that's it. That, my friends, is the destroyer script. So let's see if it works. We have to, of course, put the store all the way here at the beginning. Okay, press play and see. We need to see it move. Okay, perfect. So it is moving. And we are going to later see how it is destroyed. Make sure that it has the mover and the destroyer. Let's see if it works. Almost there. Yes, perfect. The store has been destroyed. Fantastic. Now, as you can see, we have done some work with our store. We gave it some scripts and we gave it a move speed and whatever. Now, I would like to save this work somewhere because we have to create multiple of these stores. Okay, so for this, what we're going to do is we're going to click assets. We're going to do right click and then we do create. We're going to create a new folder, okay? And we're going to call this folder prefabs. And this name is optional. You can name it whatever you want. But the point is, prefabs are basically game objects that you have prefabricated before. So you can use them over and over and over again. To turn something into a prefab, all you have to do is come here and drag it like that. And as you can see now, it became sort of bluish. You see? Bluish. Because it is a prefab. Now I can make multiple copies and they're all going to have these same settings, this same configuration, which I think is pretty cool. Because we need more buildings than that, we're going to take our prefab and we're going to do Command D, okay? And we're going to duplicate it. That's a second different prefab, right? And we're going to select the other building, building number 2, all right? So that we have the second prefab, building number 2. And as you can see, it has the same mover script and the same destroyer script. It's just easy for us, okay? So now we duplicate, Command D, Control D to duplicate. That is gonna be building 3. We come here and we say building 3. Perfect. And the same for 4 and 5. And that's it. We now have all the buildings that we need, all the prefab buildings that we need. Okay, perfect. Now we need to create one more script, and that script is going to be called the spawner script. The spawner script's job is to literally create buildings here. Okay? We're going to give it these prefabs, and we're going to say to the spawner script, make one of these buildings every 10 seconds. Choose randomly, but just make one every 10 seconds. And we're going to use the same script for the enemies, for the food, for the Gunpechu, for everything. Okay, cool. So let's go to scripts. Here, right click, create mono behavior script, and we're going to say spawner. Okay, and the spawner script is going to have a reference to all the objects that we want to spawn. And you can do this if you want. You can say header here and say references, although if you don't want to, it's okay. But here we're going to say public, and we're going to say that we want a list, an array of game objects. And we're going to call it game objects. All right, and we're done. Now, what I would like to do is I would like to, first of all, delete this store. We don't need this store anymore because we saved it here as a prefab. And then what we're going to do is we're going to do right click here and we're going to create an empty game object. This is a game object that is going to be invisible, but is going to hold the script that is going to create the buildings. Okay, so we're going to call it the building spawner. All right. And the building spawner is going to be located where we want our stores to start on. We want the stores, we want the shops to start here. Then we're going to click add component in our building spawner, and we are going to add the spawner script. And as you can see, the spawner script is asking us to put a bunch of game objects in the list of game objects. Okay, now here is where we are going to click 1, 2, 3, 4, 5 times. We're going to drag each one of these prefabs here. So these are the buildings, these are the game objects that our spawner is going to create. Now, something that we have to do is we have to select all these prefabs and we're going to change their position to 0 and 0. And the reason why we have to do this for everybody is because the building spawner is going to create the buildings. And the buildings are going to be created with a position that is relative to the position of the building spawner, of this thing right here. So I want this shop to be created at 0, 0, here, 0, 0, relative to the building spawner, which is 13 and minus 4, okay? So now let's go back to the code, because what the code is going to have to do is basically the code will choose one of these objects randomly, and then it's going to basically do what I'm doing right now with my mouse. Okay, but it's going to do it automatically for me. That's it. Choose one from here and put it here. And because they are prefabs and they have the destroyer and the mover script, they're going to move to the side automatically and they're going to be destroyed automatically. All right. So let's go. We are in our spawner. We're going to delete this. We don't need the update. We're going to say void. And here we're going to have a method called spawn. Okay. Now here we want to choose a random object. So we can do var random object equals, and we're going to say game objects. And here we want to do random range from 0 and game objects that length. So here we're basically choosing a game object and we're using random static class or the static method range. Okay, and this gives us a random number between 0 and the game object that length. Okay, that gives us a random object. This is type of game object. And by the way, you don't have to do var, you can just do the type. That is just C# for you. All right. So we have a random game object. We should create this random game object. All we have to do is literally create it. We have to do instantiate. Okay. And we want to instantiate the random game object that we just chosen. Random object that we just chosen. As a second argument of instantiate, we have to pass the position. Okay. So we're going to use the position of the spawner. Remember here, this spawner has a position here. And we can access that position by doing script, and then the script we say dot, and here we can just do transform. Okay, so we're gonna say transform that position. Okay, and here at the end it's asking us for a rotation. In our case, we are in a 2D game, so we don't need to pass a rotation. All right, so we're going to just pass a quaternion, which is how you express rotations identity. Okay, this is nothing to remember right now. Okay, so all we are doing is we are getting the object from the list of objects. Then we are instantiating that object, which means we are putting it in our scene. We are putting it in a position where the spawner is. Please remember, transform, just like game object, transform is a direct link from the script to the transform of the game object that has that script. Okay, so we put the random game object we just chose from our list. We put it where the spawner is. And we say quaternion identity, which is basically how you express rotations in Unity, like vector 2, vector 3 represent X, Y, and Z. Quaternion identity will represent rotation, but don't worry about it. All right, cool. We are now going to use a very cool function called invoke. And invoke allows you to invoke a specific method in your class. In our case, we want to invoke spawn after a certain period of time. So for example, 2 seconds like this. It's super cool. So when we call spawn, spawn is going to create our objects. Fantastic, good for us, okay? And then it's going to invoke the same function spawn after 2 seconds, which is super cool. So now all we have to do is also put it here. So start will invoke it first, and then spawn will invoke itself. It's pretty cool. All right, let's save that. And maybe start can invoke it after 1 second. And we are good to go. Okay, let's see if it works. We press play, and what I want to see is a bunch of buildings generated randomly by the, oh my god, it works. How cool is that? Fantastic. And they're randomly generated. How cool is this? We can look in the scene. There it is. You can see the spawner creating random buildings. You can see the buildings being removed. How cool is that? Fantastic, no? So the spawner just creates the game object. And because our buildings have a mover script, they move. And because our buildings have a destroyer script, they get destroyed. How cool is that? Now, I believe this is happening way too quick. So let's make some space for customization. Because my spawner is going to be used when we spawn buildings, when we spawn enemies and food, we need to customize it. Okay, we want to maybe say how often we want the buildings to show up. How often we want the enemies to show up. For example, we want the enemies to show up pretty often. We want the food to show up maybe less often because the food is healing. And we want the Gumbeju to show up very, very not often because he's very, very powerful. All right, cool. So let's come here and create another header. We can call this one header settings. Okay, and here what we want is maybe to create a minimum delay and a max delay. So we do public float minimum spawn delay. This is basically how many seconds minimum we should wait to create a new object. Okay, and we're gonna say public float max spawn delay, and here we say how many seconds maximum we should wait to create an object. Cool. So now instead of doing this, what we can do is we can say random that range. Okay, not random range like this. Okay, and we're going to pass the minimum spawn delay and the maximum spawn delay like that. Okay, so here we are going to choose a number between this and this. So if we put 5 and 7 here, for example, okay, we're going to invoke spawn in a second that is going to be more than 5, less than 7 or 7, but it's going to be random, somewhere in between. All right, cool. And I'm going to copy that same thing over here. Okay, and we are golden, done. So now we can customize our spawner. Let's reload, and here we should see now we have settings. Okay, so minimum, how much time minimum we should wait to make a building? I would say 2 seconds, maybe 3 seconds. And now here, maximum, how much time should we wait? Maximum, we should wait maybe 7, okay? Maybe 5, because I don't want buildings to not show up for 5 seconds. So this is the lower bound, maximum bound. And now I believe that here we're going to see them show up, as you can see, at different times, I guess. Yeah. So there it is. Now we're choosing, again, a number between the minimum and the maximum. All right, and they all look to be the same. Nope, they're not all the same. Okay, so it is random. All right, it is random. Now that we have our mover, our destroyer, and our spawner, we can reuse them with our enemies, with the food, and everything. Fantastic. All right, now it's time to spawn our enemies. Let's create our enemy. So here we're going to open this up, and because Unity can see that this has different images, it knows it is an animation. So we're going to select these things, and then we are going to drag them all the way to the side. That should create a new animation, put it in animations. Let's call this the Pedal Yoshi animation, or just enemy 1 animation. Or just motorbike. Okay, motorbike, done. And there it is. It's not so big. I don't know. Is it big? Is it? I think it's okay, right? Yeah, it's fine. I think it's fine. How many pixels per unit? 30. Yeah, it's not bad. How big is our character? Is 20 pixels per unit. We can maybe make the motorbike bigger by changing the pixels per unit. 20 again. How does it look? No, it's too big. It's too big. Way too big. Way too big. Way too big. So 25. Okay. No, sorry. 30 again. Yep. Leave it as it is. Okay. Let's make the enemies small. Make it easy for our guy. Okay. Cool. So now if we press play, what's gonna happen is that we can see the animation. Yeah. Not bad. The animation happens immediately. Perfect. So now all we have to do is literally change the name. So let's do enemy or just motorbike enemy or delivery enemy. Okay, delivery enemy. And we're going to add a mover. We're going to add a destroyer, right? Yeah, and that's it. Now, here we also have to add a collider. Very important, because now we want to detect a collision between our runner and the Pedal Yoshi, right? We want to know if the collision happens. So we have to create a collider. And now here we have many kinds of colliders. We can use the box collider or capture collider. Very different kinds. Let me show you. I want to zoom in here. You will see the difference between colliders. So let's click on the player, delivery guy, add component, and let's do collider. Okay, so a box collider, like easy to understand, right? It is a box. Okay, but the problem here is that if the player touches maybe this area, the collision will be detected. Maybe I don't want that. Okay, so instead of box collider, we are going to use maybe a capsule collider. And a capsule collider, I mean, it is a capsule. So we can just make it like this, for example, like that. Okay, you can make the capsule horizontal or vertical. You can then modify it like this if you want. It has an offset, so you can move what is the area that will detect the collision. That's an option, capsule collider. There are many of them. You can just do add component and look at them. There is one called composite collider, and this one will basically mix many colliders together. Okay, So for example, I create composite collider, okay? And then I can create a box collider and I can create a capsule collider, all right? Let me move my capsule. I'm gonna make it horizontal, right? And I am going to modify its borders. So here we do this, for example, and let's make it long, let's say, okay? And because we added the composite collider, we can, for example, basically decide how we're going to combine our colliders. So for example, here, I would like to only get the intersection, let's say. And also here, I would like to get the intersection between them. And as you can see now, this collider becomes the intersection between these two colliders. So you can do a lot of stuff. It's pretty nice. Now I'm going to delete this one, box collider, also composite. I just wanted to show it to you, composite and capsule, bye-bye. Okay, and we're going to use another one called the polygon collider 2D. And Polygon Collider 2D allows you to be more specific about your collider. So for example, here, you can literally click here to edit the edges. And here you can literally draw what you want to be a collider and what you don't want to be a collider. So in my case, I want this to be collider, but not the rest. Maybe here, yes. Maybe here, nope. Like that, you see? So you can be way more specific. So for example, here we can make this come inside. How cool is that? In this case, I want to maybe help the player a little bit and I don't want to be so exact. So maybe this is okay. Maybe the helmet, maybe if it touches the helmet a little bit, it wouldn't be a collision. How cool is that? Before we test this, we're going to remove the rigid body that was added automatically for us when we created the composite collider. So we remove the rigid body. Okay, and now we're going to press play and we're going to see how it works. Let's see our motorbike. Okay, and they're both colliders. The player is a box collider and the other one is a polygon collider. And as you can see, the motorbike is pushing away our player because yeah, they are colliding with each other and our player has a rigid body. So the moment that it finds a collision, it finds another object, there is a collision there, basically. Now, we don't want this. We don't want the motorbikes, the enemies, to actually push our player. But we are interested in the collision. We actually care about knowing when the collision happens. So when you don't want the colliders to affect the physics or the location of your rigid body, in this case, our player, all you have to do is take the collider and you say that it is a trigger, okay? So now this will still give us information about the collision, okay, when it happens and everything, right? But the motorbike collider is not going to actually interact with the physics of our object. As you can see here, it doesn't touch it at all, okay? If you don't make it a trigger, then there will be a physical interaction, just like our platform has a collider. And it's not a trigger because we actually want this rigid body to collide with our platform. With the delivery enemy, we don't want this. We do not want the delivery enemy to actually collide with our player and push our player, which is what happens if we unclick this box. All right, cool. So what I would like to do now is I want to save this as a prefab because now we're going to create another enemy, which is going to be the harmony and then a spawner of enemies. Okay, so we take the delivery enemy, we say 0, 0, 0. All right, and we're going to drag it here to our prefabs. And now it is a prefab that we can later use. Fantastic. Okay, next step, we're going to take our harmony. Okay, our harmony is here. All right, we click, 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 and we put it here. All right, and this is going to be the harmony animation. So we save it in the animations place, save, perfection. All right, let's play and see how it looks. We should see the harmony. Yes, look at her. Fantastic. Okay, sweet. So now maybe the harmony could be a bit bigger. Maybe she needs to be a 25 pixels per unit to grow. Maybe a nice 30 pixels per unit to grow. Sorry, 20 pixels per unit to grow. Nope, too big. 25. 25 is good. You can tweak with this later. Okay, and we're gonna take our harmony. All right, and we're going to call our harmony. Okay, and we are going to give a mover to the harmony because we want to move her, and a destroyer because we want to destroy her, of course, and we are going to give her a collider. Let's use a capsule collider. Okay, this one right here. Let me edit the bounds. So we click And let me do this. Okay. And let's change the offset like that. And here you can choose. What happens if the player touches the cane? What happens? Are you going to say it's a collision or not? You can do this. In my case, no. Okay, this will be a collision. If the player touches this, it's okay. We're gonna forgive the player. Okay, and there we go. There we go. We have the harmony. The harmony has a collider. We're going to say it is a trigger. Fantastic. We're going to touch the harmony. We're going to change the location 0 and 0. Okay, there it is. And we are going to go to prefabs and we're going to drag our harmony and we're good to go. If you want to ever edit a prefab, you just double click on the prefab and that will take you to the prefab. And if you edit one prefab, then all the clones of the prefab are going to also be updated. All right, so now we can delete the harmony. And now I am going to clone building spanner, Command D, Control D. This is going to be the enemy spawner. Okay, and I'm going to press W. Okay, W again. And this is where the enemies are going to come from. So I'm going to put them a little bit more far away because I don't want them to show up immediately. I want the player to have some time to warm up. All right. And here the enemy spawner, as you can see, is going to create buildings. We don't want that. We want the enemy spawner to create delivery enemy number 1 and harmony. And finally, we want to modify the Z dimension of our enemy spawner. We want it to be in front of the building spawner. So the building spawner is going to have, let's see what is the platform. The platform is 80. The player is -10. So the building spawner is going to maybe be 50. Okay, and the enemy spawner is going to be 20. All right, and we're good to go. So now all we have to do is press play and see what's up. So now, as you can see here, they're going to start. Yeah, look at that. We created a building. Oh, we created a delivery enemy. Perfect. Another building created. Harmony created. Fantastic. All right. Now, because the enemies start a little bit more further away, it takes more time for us to see them. Maybe I should change that. Maybe. But there it is. Look at that. There is our delivery guy coming. And we also have the harmony coming there. Fantastic. Fantastic. Cool. And again, they all have the mover script. They all have the destroyer script. So look at that. Cool, no? They're all being created. Oh, how cool is that? Super nice, no? Okay, and they're going to be destroyed. Cool. Now, what I would like to do is to know when the delivery enemy or the harmony collides with our runner, our player. Okay, and for this, we're going to tag them. We're going to give them a tag. Now, before in our code here in the player, we just check the name of the object, right? Platform, because there's only one platform. But when we create multiple harmonies, their name is different. It says harmony clone 1, harmony clone 2. So we cannot check by the name. Instead, we can check by the tag. So we're going to take delivery enemy, harmony, and we're going to create a new tag for them. Right now here, we don't have that tag. So I'm going to click add tag. Okay, we're going to click plus. This is going to be enemy. Like that, enemy. It doesn't have to be uppercase. Save. Okay. So now we can go to our prefabs again. Delivery enemy, harmony, and we can tag them both. They are both enemies. Fantastic. All right. Cool. So now in our code here, we can open our player, and here we're going to implement another method that is called when we collide with a trigger. So we're gonna say void. We're gonna say on trigger enter 2D. On trigger enter 2D. Here we're going to receive the collider 2D that we just collided with. So we say collider. Okay, and all we have to do is check. We're gonna say if collider.gameObject.tag is equals to enemy. That means that we just hit an enemy. And in the future, we can just put it here. We can do else if collider.tag equals food. And this has to be double quotes. Okay, and that's it. So here you are going to basically check if you hit an enemy, if you hit food, and actually also here else if collider.gameObject.tag equals, and here we're gonna call this the golden pechu or just golden, whatever. Done. So let's now include the food and let's include the golden pechu, shall we? Let's go. So we need the garlic. And we're going to grab the garlic here and see how big it is. It's very small garlic. Okay, so we're going to touch the garlic, the bechu. garlic, bechu, and gochu, the three of them. We're going to change their pixels per unit to maybe be 20. Apply. That's huge. Sorry, we don't want big garlics like that. Okay, 30 and maybe 35. All right, and we are done. Perfect. And we're going to make a prefab out of them. Okay, so here we have the garlic. We need to give it a mover. Yes. We need to give it a destroyer. Yes. And we need to give it a box collider 2D. Perfect. Done. So that is our garlic prefab done. How cool is that? We are reusing so much. We come here, we can say garlic. All right, and we're going to drag and drop garlic. Perfect. And now I'm gonna do Command or Control D, and garlic 1 is going to now be gochu. And all I have to do is click on gochu and go to sprite, and I have to find the gochu. There it is. And now we have a gochu prefab. I will duplicate Command D, Control D. And now we need to have the, what is it? Bechu. Bechu. Okay. And I will just click on the bechu. All right. And I will select the bechu there. Where are you? There it is. Done. Perfect. Okay. And now we have 1, 2, 3 prefabs. Perfect. I am going to delete the garlic from here. Don't need it anymore. And now we're going to create a tag for them because our script is looking for them as a food tag. All right, so we come here, we're gonna create a new tag. Perfect, plus, and we call this food. Okay, and let's create the golden one that we talked about before. Perfect, so now we go back to prefabs, select your bechu, select your garlic, select your gochu, and now we're going to tag them as food. Perfect, and don't forget the three of them, bechu, garlic, gochu. They need to be a box collider and they need to be a trigger. Very, very important. Okay, bechu needs to be a trigger, garlic needs to be a trigger, and bechu also, well, they all have to be a trigger basically. Okay, and if you want to, you can double click them, okay, and you can modify their colliders if that's what you want. Okay, so you can click your bechu and modify its collider. This is okay, I think. I don't want to make it harder to reach. The same for the garlic, I guess it's fine. And the gochu, yeah, it's fine. I don't want to make it harder to reach. Remember, this green line is the collider bounce. All right, so now all is left is we're going to duplicate the enemy spawner. We're going to call it food spawner. Okay, we're going to find it. Where is it? Very far away. Okay, let's put it here. And again, you can tweak this later to make it look better. I'm gonna do it off camera. Okay, and we don't want the food spawner to create delivery enemies and harmonies. We wanted to create garlics, gochus, and bechus. Okay, all right, and we're done. Now let's see if it works. We're going to press play, and we now have created all of them. I mean, we need the golden one, but I guess that's it. So let's see. As you can see, garlic was created, harmony created, building created, bechu created, harmony. Fantastic. Where are they? Oh, there they are. How cool is that? Okay, cool. But the problem is that ideally the user should be able or should have to jump to reach it, right? Yeah. So I believe what we should do is we can elevate the food spawner origin, because this is the origin. We want the user to jump to grab it, right? Okay. And that's it, we're done. Let me go to scene and we should see our food show up from here. Finally, we are going to do this one, the golden one, that is going to be very, very easy. So we're gonna go to sprites. We're going to take the gold bechu and we are going to give it a 35 pixels per unit. Okay, we're going to drag our gold bechu there so we can see it. Fantastic. All right, and we're going to do the same thing that we did before. We're going to give it a box collider. We're going to turn that into a trigger. We are going to give it a mover that is going to move the bechu and a destroyer that is going to destroy the bechu. All right, now we're going to go to prefabs. We're going to drag the bechu here. Okay, and the bechu, because it's glowing, as you can see here, the box collider is pretty big and I don't want that. So let's modify a little bit here. So that's the collider. So that's the collider. There we go. And last but not least, we have to give it a tag. We already created the tag. So tag is going to be golden. Okay, perfect. And then now we're going to take the food spawner, duplicate it. This one will be the gold spawner. All right, and we are going to maybe change its location. Somewhere here, whatever. I'm just changing location because I want them to show up a little bit later in the game, okay? And we take the gold spawner and we're going to delete. All right, and we are going to drag this. Oh, I already did that. Okay, so sorry about that. Let me delete this one, delete this prefab. Okay, and let's call this one golden Baechu. Okay, and just drag the golden Baechu to our gold spawner. And we are golden. Okay, and we're done. Did we give it a tag? Yes, it has a tag. Okay. And we are done. We are done spawning enemies, spawning buildings, spawning food, spawning healing Pechu, everything. Now, of course, we have to work on the timing. We have to make maybe the buildings show up quicker. The enemies also have to show up quicker. Maybe the food shouldn't show up so quick because the food is healing. Okay, there it is, the food being scrolled. Nice. Okay, and the golden Pechu is also showing. Perfect. Good. So we have our enemies, we have everything. Cool. Now, take some time and you will tweak the settings. You can make things faster, slower, so it shows up well. All right, and as you can see here, as I touch this, yeah, I'm okay. I can touch the food because it's just a trigger. Yeah, nothing here is pushing the player. Fantastic. All right. I tweaked the game a little bit. I changed the speed of our obstacles and I also modified the speed of the spawners. Okay, so now everything looks a little bit better. All right, and now what we have to do next, the last thing we're gonna do, one of the last things is we're going to murder the player. We're gonna kill the player. Okay, cool. So let's remember the rules. When we eat one of these foods, garlic, gochu, and bechu, okay, we're going to get healed. That's gonna give us a life. When we hit the delivery enemy or the harmony, we're going to lose 1 life. All right, and when we drink or touch the golden bechu, we're going to become untouchable for 5 seconds. That means that the harmony and the delivery enemy cannot touch us. All right, cool. Okay, let's go to our player, and here we're going to say private. All right, and that is going to be an integer for the lives. Okay, we're gonna start with 3. All right, and also private, there's going to be a boolean, and we're gonna say is untouchable, or let's do is invincible. Okay, and by default it is false. Okay, perfect. So now, if we touch an enemy, we're going to run a method called hit. If we touch a food, we're going to run a method called heal. And if we touch the golden bechu, we're going to run a method called start invincible. So long. Okay, now, if we touch an enemy or if we touch a food, we are going to basically destroy that thing that we touched, right? We want to remove it because we touched it. Okay, so we're going to come here and say destroy the collider that game object, destroy collider that game object. Okay, but we only want to destroy the enemy if we are not invincible. So I'm going to say if not is invincible, then we're going to destroy the enemy. Okay, now the food, we're always going to destroy it, always. Okay, remember, collider that game object is the game object that just collided with our player. Okay, and the golden pechu we are also going to destroy. Okay, cool. Now let's implement hit, heal, and start invincible. Okay. All right, so when we get hit, let's come here to void hit. When we get hit, we're going to take lives and we're gonna do minus equals 1. That is the same as doing lives equals lives minus 1. Same. Okay, so lives minus equals 1. Okay. Now let's do heal. Okay, and this is something that is going to happen when we eat a food. Okay, so what that means is that we have to do lives plus equals 1, but the problem here is that if we already have 3 lives, we don't want to increase those lives. Okay, so we have to cap it. We're gonna do equals, we're gonna do math for math functions. Okay, and we are going to say minimum. Okay, 3 or the current lives plus 1. Okay, so what does this mean? What this means is that if, for example, for some reason, lives was going to be 4, mathfmin is going to give us the smallest number of the two. Okay, so here we're capping lives at 3. So even if we keep eating food and food and food, we are never going to be healed because this function is always going to choose the smallest number. And that should be 3 or 2 or 1, depending if we are hurt. All right, so we say lives plus 1. Perfect, done. Now we need one more, and that is start invincible. Don't forget the semicolon and start invincible. All right, so start invincible will turn us into an invisible player. Invincible. So we say void start invincible. Okay, and here we're gonna say is invincible equals true, and then let's make another method called stop invincible. Okay, and this is gonna turn us into is invincible equals false. All right, and now when we start becoming invincible, we are going to say invoke. We want to invoke stop invincible. So here, okay, after 5 seconds, and we are good to go. Okay, so if we eat an enemy or an object tagged with an enemy and we are not invincible, we are going to destroy that game object, and we are also going to get hit if we are not invincible. Now, if we eat some food, we destroy the food and we get healed, which is going to increase our lives by 1. And if we have the golden pechu, we destroy the golden pechu and then we become invincible. There it is, start invincible, and we invoke, we schedule an invocation for stop invincible after 5 seconds. Sweet. Now what I would like to do is I want to kill the player. Literally, I want to kill the player. I want to show the player something happening to the player when the player dies. Okay, some animation. So here I'm going to say void kill player, and this should happen when our lives reach 0. When the player dies, I want to make an effect like the death of Mario, where when Mario dies, he jumps one last time and then he falls. He doesn't collide with anything under that, he just falls. Okay, so what that means is we have to stop the animation, we have to do this, and also we have to disable the box collider, and that means that it's going to jump, it's going to fall, and it's not going to touch the platform. That means that in our script we need to ask for the collider. So here let's do public box collider 2D, and let's say player collider. All right, so now in our kill player we're going to say player collider, we're gonna say enabled is false. That is like unchecking that box that I just showed you. And then we do player animator enabled is false. And let's make the player jump one last time. This one right here. Okay, and we're done. So that will be kill player. Now kill player is going to be called here. If lives equals 0, then we're going to kill the player. All right, and later we're gonna stop the game when that happens and all those things. But for now, that's it. I just wanna see that it works. All right, cool. So we come here, and now our player script is going to be asking us to give it the box collider. So let's put the box collider there. Perfect, we're gonna press play, and let's see if it works. Now, I am not going to avoid any harmony or pedal a Yoshi, so we're going to die, I guess. So that is 3 lives, 2 lives. All right, they're coming up. Again, 1 life, and boop, I jump, and bye-bye. Perfect. That's exactly what we want. And as you can see, this is working. We are destroying the object that we collide with when we hit an enemy. Now let's check if what happens when I hit some food. I would like to get healed, of course. And then, of course, we need to become invincible with the golden pechu. All right? Okay, so let's see if it works. I have 3 lives, of course. We're going to receive a enemy. Yes. Another enemy. Yes. And now I will heal myself, so I can touch this fella and I'm okay. Yes, perfect. So this heals me. Fantastic. Now we're going to become invincible. We touch the golden pechu, and now as you can see, if I touch the harmony, nothing happens to me because I am invincible. But now I stop being invincible and now I got hurt again. Sweet. I will get healed again, and it's working. Fantastic, everybody. Good job. And there we go. If you wanted to see your lives, you can just make them public here. Public. And also, it's invincible. You can make it public. And that's it. So now you will see it here. So you see what's going on. All right. And we're good to go. As you can see now, lives is 0, is invincible is false. But now, of course, if I start again, lives will be 3 and is invincible will be false. And you can actually just monitor your game here. You see? So lives is 3, just checking that everything works. And now I touch the enemy and now lives is 2. Perfect. And now lives is 1. Perfect. And now I touch the food. And now lives is 2 again. Life is 1 again. Yeah, working. So now I only have 1 life. Be very careful now. And now I got healed. Look at that. I got healed. And now I am invincible. You see? Look, I'm invincible. And in 5 seconds, I'm going to stop being invincible. And it's working fantastically well. Perfect, everybody. We are absolutely done. Now, my friends, what we have to do is we have to create a UI, a user interface. Okay, I want to create a nice intro. Okay, and I also want to handle what happens when the player dies. We want to be able to restart the game. And also, last but not least, I want to show the user their current score. Okay, and I want to make the game more difficult because right now the game is not becoming more difficult. It's just the same. We want to basically make the game go faster. We want the obstacles to go faster as the game advances. All right, so it's time for the absolutely epic game manager. We're gonna come here. We're going to create an empty object. This is going to be the game manager, and the game manager is going to manage our game. The game manager will know how many lives we have. It is going to show the interface for the intro. It is going to restart the game when we die, all of those things. Okay, so we're going to go to scripts. We're going to do right click, create mono behavior script, game manager. All right, manager. Sweet. Now we're going to select the game manager and we're going to put the game manager script in the game manager object. So game manager here and boom. So now we have a game manager and we are ready. Let's open the game manager and let's get started. For the game manager to be able to manage our game, it needs to be accessible by everybody else. And we need to make sure that there is only one game manager at all times. So for this reason, we're going to come here and we're going to create a public static property of this game manager class that is going to be type game manager and is going to be called instance like this. Then in a method called awake, which is a method that is called by Unity automatically before start, we're going to say if instance is equals to null, then instance is equals to this. This way, we are able to share our game manager instance with every other script in the game, right? Cool. So what is the game manager going to do? Well, the game manager is going to manage the game state. So for this, I will create an enum here, public, okay, enum called game state. We're going to have the intro state, the playing state, and the dead state. And we're going to share this with everybody. We're going to say public game state, and we say the state of the game is equals to intro. All right, and we're good to go. So now we can share this with the player, for example. And in the player, if we are not in game state.play, maybe the user shouldn't be able to jump. Okay, something like that. All right. Before the game actually starts, we want to show to the user the title of the game and tap to start. So when they tap, when they press space for the first time, then the game will start and the enemies will start spawning and everything. So you're going to go to start button and KIMCHI-RUN and make sure that sprite mode is single. Okay, no compression, click apply. Perfect. And now we're going to create a new empty game object here. All right, so create empty. And we call this the intro UI. Perfect. Then we're going to drag KIMCHI-RUN into the hierarchy and the start button as well. And we're going to put them inside of intro UI. All right, now take the title and you can scale it as much as you want. You can make it look as cool as you want. So we're gonna put it here in the center, KIMCHI-RUN, okay. And then the start button also. Let's do this and make it bigger. All right. Boom, tap to start, okay. Let's center both of them in the x-axis 0. Perfect, and how does it look? Looks good. All right, you can make it bigger, you can make it go up. Let's make it go up. Okay, and let's make it bigger here. Okay, and don't forget to press Control so it resizes as well. Fantastic. Okay, so this is the intro UI. We want to give this intro UI to our game manager because our game manager is going to show the intro UI and is also going to hide the intro UI. Okay, so let's do it. We come here, game manager, and we are going to get references. So let's do header here, references. Okay, and that'll be public game object, and this is the intro UI. All right. So when our game manager awakes, our game manager is going to enable the intro UI. The intro UI is going to first start disabled here like this. It's going to be invisible, right? Invisible, and we're going to enable it. So let's take the game manager, and here we're going to give it the intro UI. So when the game manager starts, when the game starts, we're going to say intro UI that set active true. All right, perfect, fantastic. What we have to do next is we have to detect when the user presses space for the first time. That will start the game. That should hide the intro UI, okay? So we're gonna come here and we're gonna just copy this part because it's the same thing, but we're going to be detecting that here in the update function, okay? So we're going to say that if the state of the game, so if the state of the game is equals to game state.intro, okay, and we realize that the user pressed the space bar, okay, we're going to change the state of the game to game state that playing, and we're also going to hide the intro UI. So we say intro UI set active false. Now when we are in the intro UI, I don't want the enemies to show up because that would kill the player even before we start playing the game. So what I'm going to do is here I am going to ask for more references, and I will say that here I want the game object. And this one is going to be the enemy spawner. Okay. I also want the food spawner, and I also want the golden spawner. Golden spawner. All right. And when the game starts, when the game manager starts, I want them to be disabled by default, I believe. Yeah. So we're going to go to Unity, and we're actually going to disable enemy, food, and gold spawner because we don't want them to be active creating stuff before the game even begins. So we're going to select them all, and we are going to unselect them from here. That will disable them. Okay. But of course, we have to give them to the game manager. So I'm going to drag and drop the enemy one, the food one, and the gold spawner. You can use an array and list if you want, but I think this is easier. All right, so when the user presses the space key and we are looking at the intro, we are going to hide the intro UI, okay? And we are going to activate all these spawners, the enemy spawner, the food spawner, and the golden spawner. Okay, done. So set active to true, all of them. Okay, when again the user presses the down key and we are in the intro state, which only happens once. Okay, perfect. So now they're active. That means that now we have to go to our spawner, and we should not use start. Instead, we're gonna use on enable, and this is a method that gets called when we enable the element. Okay, when I come here and I click, that will trigger on disable, and if I enable it again, that will trigger on enable. Okay, so when the enemy spawner, food spawner, and gold spawner are enabled, then we want to invoke spawn for the first time and then do all the things we do here. Cool? Cool. All right, let's save this. Let's save that. So that is the intro, and that is what happens when we are playing. That is how the game begins. Let's see if that works. Okay, what we should do the moment I press play is we should see the intro only the intro screen. Okay, let's see. Okay, as you can see, they are disabled. Enemy, food, and gold are disabled, right? And we are only getting buildings. That's fantastic. We're only seeing the buildings. That is sweet. Perfect. Now the player is fine. That's exactly what I want. This is the perfect intro. Now I press space, and as you can see now, the food spawner, gold spawner, game manager, they're all enabled. And now as you can see, they start to show up. Okay, perfect, that's exactly what I want. Cool, so we have intro and we have playing state. Fantastic. Now, what we need to do is we need to kill the player. But the player is not going to be killed in the player script. And the reason why is because I want the game manager to also know when the player dies, because we want to disable these things, because when the player dies, we don't want to keep spawning enemies and food and everything. And I also want to maybe show the dead UI, maybe showing the high score and restarting the game. Okay, so for this reason, we are going to create the lives here. We're gonna say public, okay, integer, and lives. We're going to move the logic of lives, not in the player, but we're gonna put it in the game manager, all right? So here we're going to delete the lives, okay? And here, instead of doing this, we're going to say game manager.instance.lives. Okay, the same thing, but this we don't need. Okay, and the same here as well, game manager.instance.lives. So we're basically moving the counter from the player to the game manager, that instance.lives. Okay, because we want, again, the game manager to be the one that knows when the player dies. Now, because we have here a method to kill the player, to make the animation, I'm gonna go to the game manager, and here I want a reference to the player script. So I wanna say player here and player script. Okay, done. So now here in my update function, I can say if state is equals to the game state.playing and lives is equals to 0, I will do player script dot kill player, right? That's the name? Yeah, kill player. I have to make this public. Okay, and I will do kill player, and we're good to go. I also want to disable all these things, so copy this and change to false. Okay, and of course I have to change the state. So the state of the game is now game state.dead. Perfect. All right. Now, if the state is dead, so here I want to do if the state is equals to dead, okay, and the user presses the space key again, okay, maybe here we can restart the game. We can reload the scene. Thankfully, it is very easy to reload the scene. We can say scene manager dot load scene, and that is going to be main, the name of our scene, and we are good to go. Now, something that we shouldn't forget is that when we enable the spawner, we are invoking spawn, and then spawn is invoking spawn again. But if the user dies, we want to cancel whatever invocation is scheduled, because maybe the user dies now and there is a spawn that is scheduled in 20 seconds. So that is going to still happen. So we have to cancel that spawn. So we're gonna come here and say void on disable. We're going to cancel the invoke. It's not a big deal, I just wanna do it to show you. All right, and we're good to go. Now I guess we have to just check it out. Let's go to Unity. Game state is equals to intro. So we see the intro, and as you can see, all the spawners are disabled. Press space, they are now enabled. Perfect. Okay, we have to hit 3 enemies. So then the game manager kills the player and changes the state. Almost there. One more. Okay, and now as you can see here, the spawners are disabled, and then eventually all of these ones are going to disappear apart from the buildings, because the buildings, they are always enabled, because we always want to see the buildings. There it is, look at that. So now no user, nobody. Later, of course, here we can show the high score. Okay, now we're gonna press start, oh, sorry, not start, space again, and as you can see, that is going to reload the scene. Fantastic. All right, and we start playing again. Let's now create the dead UI. So let's do right click, create empty, and dead UI. And this one is going to be very simple. We're just going to drag and drop, tap to start to the dead UI. So they know they have to tap to go back to the beginning. That's it, easy. And we're going to disable that by default, and we're going to give the dead UI to our game manager. Just as we have intro UI, we're going to have dead UI. So So that UI. Okay, and here, when the user dies, here we're going to say that UI set active is true. Don't forget to give the dead UI to the manager, so dead UI to the manager, perfect. And now we're going to build the hearts. We're going to put the hearts here. So we're going to take heart on and we're going to drag it all the way here, and there is our heart. Okay, make sure that you change the pixels per unit of both of them, of the heart on and the heart off. Maybe we're going to do a 20 and we're going to apply. All right, and now we're going to put our heart here. Later we're going to duplicate many hearts. All right, for now just one heart because we want to make a prefab. Okay, now I'm going to create a script, and this script is going to be called heart. I already created it here. Perfect. This script is going to have a reference to two sprites. Okay, one is going to be the sprite that shows me the heart off, and the other one is going to be the sprite that shows me the heart on. That's pretty easy to understand, right? And we're going to switch them depending on how many lives the user has. So I'm going to do public, and this is the sprite, and I will do on heart, and then public. This is the sprite, and I will do off heart. Okay, and finally, here I'm going to say what number of live this is. So I'm going to say public int live number. All right, and also I would like to get the sprite renderer here, sprite renderer. Let's do it. Okay, because the sprite renderer is the one that renders the sprites. Okay, and I have to switch the sprites. So let's go back to Unity. I am going to add a heart component to my heart, and here, as you can see, I have the option to pass the heart on, the heart off, okay, and the sprite renderer. Perfect. Okay, and now I'm going to duplicate this, Command D. So take your heart and then Command D, and you move it here. And live number is going to be 2. Here, live number is going to be 1. Okay, and again here. All right, and 3. Perfect. So now here in our update, we're going to say that if the game manager at instance that lives is more than or equals to the live number, then we're going to take the sprite renderer and we're going to say sprite is equals to on heart, else sprite renderer sprite is equals to off heart. All right. So now we play the game and we have 3 lives, so all of them are turned on. And now when I lose a life, as you can see, we switched this sprite. And we changed the sprites. Fantastic. Now we're going to calculate the score and show the score to the user. Now, the score is going to be calculated in how many seconds basically the user survives. So in our game manager, we're going to say public float, and we're going to say play start time. Okay? And when the game starts, not the actual game, but when the user starts playing, we're going to save that. So I'm going to say play start time, that is equals to time. Okay, and that's it. Perfect. So now the score, let's make a function here, void calculate score. The score is going to be equals to the current time minus the play start time. Done. That is going to be our score. Now we're going to make a function to save the high score. So we're going to say void save high score. And we're going to take the current score. So let's do float score. We actually want to turn that into an integer to save it as an integer. So I'm going to say matf and I'm going to say floor to integer. All right. And I will just do calculate score. Okay, perfect. And now what I have to do is I have to get the current high score. And we haven't done this before, but we're going to do it for the first time. I want to get the current high score. Okay, and for this, we're going to use player preferences, which is a class that allows us to store data in the disk of the user, which is super cool. And here we're going to get the integer named, let's say, high score. And this is something we save in the device of the user. We can just access it like this. Now, this happens synchronously. If it happened asynchronously, we will be doing something like await, because now C# and Unity, they support async and await, which is pretty cool. All right, so now we're done there. And now we check if the score is more than the current high score. If that's true, then we're going to do player preferences, and we're going to set integer called high score. So all we're doing here is getting something from the disk of the user and then saving something to the disk of the user if the score is more than the current high score. And we're gonna come here and we're going to save that score like that. Okay, and of course we have to do player preferences that save. Okay, and we're done. To show the user their score, we're going to come here, we're gonna do right click and we're going to create a new canvas right here, canvas in the UI section because we want to paint text now. All right, and we're gonna call this just canvas. It can be called canvas, as you can see, is in a weird location. So we're going to change this from overlay to camera. All right, that's it. And we're going to drag and drop the camera that we have. Okay, that's it. So now this canvas is going to operate in the same level as our camera. Perfect. We're gonna do right click, UI. We're gonna create text. All right. Now here you will see this that is saying that you need to import something. You're gonna click import EMP essentials. Okay, and that's it. You're good to go. So that creates a text. Look at that. All right, we're going to put this text here at the top. All right, and it's going to start, the text is going to start with score 0, like that. Score 0. There it is. Score 0. All right. And now all we have to do next is we have to drag a reference to this text to our game manager so we can paint the current score in the screen. Okay, so let's go to our game manager, and here we need another reference. Let's do public TMP text, which is the type of text. We call this a score text. All right, we save that, and now here when we are in the update, we can say that if state is game state dot plain, we want to take that score text, and make it equals to score, and now here we want to do plus calculate score. All right, and this is going to be a float, so we're going to basically copy this. All right, and put it here. Okay, and we're done. So now we have to go back to Unity. We have to go to the game manager and we have to drag and drop the text, the score text. Boom. Okay, now we press play. And now, as you can see, the score is not being updated, but the moment the game starts, the score will start updating. Fantastic. Now I am going to die on purpose. Okay. And done. Okay, as you can see, the score stops being updated. And what we can do is we can say else if here the state is equals to game state dead. So if we are dead, we can say score text that text. Here we say high score. Okay, and then here we can just do get high score, which we are about to implement here. Void get high score. Perfect, and that is this thing, literally. We just return this, get int. Okay, and this returns an integer. Okay, and we're done. So if we are dead, we're going to see what is the high score, and that's it. And I just played, and look at this. This is my high score, everybody, 19. That's my high score. You can see it works very, very well. If you want to, you can select your text, and here you can make it bigger, make it smaller. You can change the font size, the font, whatever you want, even the color and everything. All right. Now, the last thing I want to do is I would like to make my game accelerate. So the higher the score of the user, the harder the game should be. So I want everything to move faster. Right now, our mover is moving everything at a speed that we set, but it's not increasing. We want to change this. And instead of doing move speed, we want the game to accelerate and everything to move quicker. All the obstacles to move quicker, everything to move quicker. So I'm gonna make a method that is going to return a float that is going to tell me the game speed. So it will be calculate, not score, but game speed. Okay, so if we are not playing, so if the state is not equals to game state at playing, okay, so if we are not playing, we'll return maybe normal speed, 3F, 5S, F, whatever you want. Else, we're going to calculate the speed like this. We're going to say speed equals to, and then the initial speed, okay, plus, and here we're going to take the speed just 0.5, a little bit higher, okay? We're going to do mat f that floor, and we're going to take the current score, calculate score, okay, divided by 10. So every 10 seconds, I would like to increase this speed by 0.5. Okay, that's it. Cool. And we're going to return matf that min, and maybe we'll return the speed. and the maximum speed. So what should be the maximum speed? I would say 20. That's a maximum speed. Okay, so here we're going to return either the speed or the maximum speed. Now we have to go to mover. We're going to replace move speed for game manager that instance that get or calculate game speed. Okay, so now they're all going to move according to the game manager, which means that they're going to accelerate as the time goes by. When the score increases, everything will accelerate. The same for the background scroll. Here you can do scroll speed times game manager instance, calculate the speed, and we're good to go. Now it will help to divide this by 20 or something like that because our platform on the X scale is 20, right? Okay, and we're done. You can play with this. Maybe 5 should be good or 10. I don't know, I think 5 is good. And maybe when the game starts 8, something like that. And maybe maximum speed should be 30. That is your call. And if now we play this, of course we have to tweak the time, and you can go to your spawner and you can tweak the minimum and the maximum time because now everything will go faster. Perfect. But now what I want is I want the buildings and I want the motorbikes to move all at the same speed. Yeah, and they're moving all the same. Everything is moving at the same speed. The buildings, the enemies, and the food is all moving at the same speed. Look at that. You see? They're moving at the same speed. So that means that the food is also going to start moving quicker as the enemies start moving quicker as well. Okay, cool. And now, like I say, because we modified this speed thing, now you, my friend, have to go back to the spanners here and change the numbers to something that you like. Maybe you want to show the enemies more often, less often. That is your call. All right, but for now, we're good, and I'm very happy with what we got. To publish this game, you're going to go to File, then you're going to go to Build Profiles, and then you're going to click on Web. You're going to say Switch Platform because you want to make this game for the web, okay? Not for macOS or Windows or whatever, okay? Then you're going to go to Window, Package Manager. You're going to click here on your Unity registry, and you're going to search for WebGL Publisher. This is what you're going to now click Install. Okay, that is the package that is going to help you publish your game on the web for free. Finally, that after you install it and after you switched to the web platform, you're going to see a menu here that says Publish. You're going to click WebGL Project. Okay, you're going to click Get Started, and you're going to click Build and Publish. They're going to ask you where to put the build or the game that you're going to build. You're going to select that. Okay, you're going to save your scene, and then you're going to wait until this is done. Now, every time you change a setting on a script, or maybe you modify the time in the spawner, in the enemy spawner, or golden spawner, food spawner, whatever, you have to publish again. All right, just remember that. Once the build is finished, you can click on Publish, and that is going to upload your game to Unity Play. That is going to open this website where you can change the name. So KIMCHI-RUN by Nico. Okay, and you can say if it's public or not, and update. And description, make kimchi never die. Okay, update. And it's done. So now, as you can see, it's ready. People can click play. You can share this link with anybody, and it's done. Now you can play. You can press start and start jumping, and you are good to go. If you want the text to always be in the same position, no matter the viewport of the user, you're going to click on the canvas, and then you're going to set that to world space. Then you're going to click on the text, and you're going to anchor the text to the top left corner. And once you're done, you're going to click Publish, WebGL again, and you're going to create and publish a new build. You're going to replace, and that's it. Look at that beauty. Good job, everybody. Now your game is on the web. Congrats. Perfect. Thank you for following along. Thank you. I hope you liked it. I hope you enjoyed it. Making games is so much fun for me. Of course, this game could improve more. I think you have to spend more time perfecting the physics and how much to jump, and maybe the speed of the buildings, the speed of the enemies, how fast they should go, and all those things. But we have a very good starting point for a very awesome, super cool game. So that's it. Thank you for watching, and let me know what your high score is. You now have this link, so you can share it whatever you need to share it to your friends or to enter the contest. See you in the next one. Bye bye.